activities and transportation. Members met to hear about cost estimates of the proposed NASA manned space station. They also take testimony on the scientific validity of the project. At issue is whether NASA's estimates of the costs of the space station Freedom, as it's called, square with the estimates given by independent analyses. Witnesses before the panel include the Comptroller General, Charles Bowsher, NASA Administrator Richard Truly, and representatives from groups such as the Space Studies Board of the National Academy of Sciences, the American Geophysical Union, the Federation of American Scientists, and the American Physical Society.
Pursuant to Rule 10 and 11 of the Rules of the House of Representatives, this subcommittee has the responsibility to oversee the programs and activities of several governmental entities, including the National Aeronautics and Space Administration. Today, the subcommittee will be examining the cost, justification, and feasibility of one of NASA's major activities, the Space Station Freedom program. The exploration of space has provided numerous benefits to the people of this planet. Through hard work and determination at NASA, we've been able to use our knowledge of space to develop such advantages as satellite communication networks, which have helped unite the distant nations in ways which have been unthinkable only a generation ago. Remote sensing from space to help us understand and hopefully mitigate the process of global change. And exploration projects such as the Apollo program and the Explorer and Voyager programs, which expanded our knowledge of the universe and inspired a generation of scientists and students. However, NASA, like everything else and everyone else, is not invulnerable. The controversy surrounding the Space Station Freedom program has led us to this hearing today. The subcommittee has found that the space station's cost has been vastly underreported to the Congress. Its long list of promised capabilities have dwindled down to a pair of missions that renowned scientists say have little merit in relation to the cost. And the vehicle necessary for its assembly and operation, the Space Shuttle, has reliability problems. The first goal of this hearing is to clarify, possibly for the very first time, exactly what the space station program will ultimately cost the United States taxpayer. The hardworking people of this country deserve to know precisely how much of their tax dollars are going toward this space station program. For at least the past 11 years, the GAO has repeatedly reported to the Congress that NASA does not fully report the costs of its programs to the Congress. For example, in 1980, GAO stated the following, and I quote, "NASA has underestimated the costs for some of its major projects. Generally, the Congress does not routinely receive information on the total project cost or changes in the cost for all NASA projects." 8 years later, in 1988, GAO again reported that, and I quote, "NASA does not typically report the full cost of its projects to the Congress." Finally, as recently as March 1st, 1991, GAO stated that regarding the space station program, quote, "Current reports on costs do not include adequate information," unquote. In 1972, NASA told the Congress that the Space Shuttle program would cost about $6.5 billion. As of this fiscal year, the Congress has appropriated $42.5 billion and counting. How many more GAO reports do we need before NASA begins to tell us the whole story? NASA has repeatedly described the station program as a $30 billion project and has stated in its 1988 Space Station Freedom booklet on page 6 that the space station is a 30-year program. In fact, our subcommittee investigation has established that the true cost of this project will be approximately $180 billion plus inflation over its lifetime. $180 billion, not $30 billion. And I would like to explain how the subcommittee derived this figure. First, I believe that the $30 billion NASA estimate will get us a garage in space with nothing in it and nothing happening around it. Not only does the $30 billion fail to account for tens of billions in operating and other costs once the station is up and running, but it does not even fully account for the initial phase of the program, which will be at least $51.8 billion. The following are only some of the costs that are not included in NASA's $30 billion estimate. First, the crew return vehicle. This is an escape vehicle which would be used to remove the astronauts from the station in the event of an emergency. While the design for this has not yet been finalized, NASA estimates that it will cost between $1.5 billion to $2 billion, with the higher figure being more likely. This also will need to be added to the NASA estimate. In addition, this crew return vehicle is only being built for 4 people. If the station grows back to an 8-person crew, as NASA has told its international partners that it intends to do, then more funds will be needed to either adapt the return vehicle for 8 people or the more likely event of designing and building a new one for billions more. Transportation costs, the second group of costs not included in the estimate. Transportation costs of the shuttle, which will be used to transport the components of the station into space, are estimated to be about $615 million per shuttle flight in fiscal year 1990. Assuming no mishaps along the way, the redesigned station will require 26 flights to assemble and utilize the station. At $650 million per flight, in non-inflated dollars, the transportation for this phase of the program adds $16 billion. Third, microgravity research and life sciences equipment. All of the equipment on board the space station will be mounted in metal racks in the station. Precursors of these racks were used on the space shuttle, and at the time cost about $100 million per double rack. These racks will likely cost more on the space station because of stricter requirements. There are going to be 28 double racks for the United States on the station. These costs will add another $2.8 billion to the NASA estimate. In addition, since NASA has recently agreed to add a centrifuge to the station, this will add another $1 billion or so to the program. Therefore, the initial cost for this category is about $3.8 billion. The word initial is used because over the 30-year life of the station, the scientific equipment will need to be updated and replaced, possibly several times over the life of the station, and we haven't even included that. The NASA estimate of $30 billion also does not include billions that will be incurred after the space station becomes permanently occupied after the year 2000. The station will be expected to operate until at least 2027, and the following are examples of some of the costs that need to be added to the NASA $30 billion estimate. Operations costs. The station is expected to operate for 30 years, according to NASA. The current NASA estimate for supporting the station after it's permanently occupied is $2.025 billion per year, adding at least another $54.68 billion in non-inflated dollars to the NASA estimate. This figure does not include salaries, which would add another $7 billion to $8 billion to the $54.68 billion figure, bringing a grand total of operations costs of about $62 billion. Transportation costs. After the station is permanently occupied, the shuttle will supply the station with 4 logistics flights to deliver air, food, and so forth per year to support it. This adds up to about 108 flights. At $615 million per flight in non-inflated dollars, the transportation costs add at least another $66 billion to the NASA estimate. Infrastructure costs. This includes the buildings and facilities that will need to be built for testing and assembling the various equipment and components prior to having them sent into space, and will add hundreds of millions of dollars to the program costs. Therefore, the subcommittee has determined that $150 billion in costs are not included in NASA's estimates of $30 billion, bringing the total to approximately $180 billion. The second goal of this hearing is to determine whether the remaining justifications for proceeding with the station are sufficient to support these astronomical expenditures. If the most compelling reason for building the space station, and this was stated by very high elected officials in the administration, if the most compelling reason for building the space station is that it will further American leadership in space, then it is prudent to ascertain if there are more cost-effective ways of achieving this goal than the plan now laid before us. The subcommittee is fortunate in that today we will hear from a panel of science and space experts who will provide their views on alternate courses of action that the United States can take to make the United States a true leader in space. No less a source than Alan Bromley, the White House science advisor, recently stated in his March 11, 1991 study that, and I quote, "Neither the commercial processes nor the scientific merit of the microgravity experiments come close to justifying the cost and effort required to build, deploy, and operate the station." And I assume Mr. Bromley is talking about a $30 billion program, not a $180 billion program. Today we will discuss the reliability of the space shuttle, which will be used to deploy, service, and resupply the space station. Initially, NASA stated that the shuttle would fly about 60 missions per year. They are currently averaging about 6 missions per year. In addition, the shuttle has also experienced reliability and usability problems such as accelerated component wear-out and longer than expected maintenance times. We will also discuss the contributions of our allies. The European Space Agency and Japan will each place modules on the station at a cost of $4.5 billion and $2.2 billion, respectively. Our experience with shared military ventures compels us to ensure that our allies are paying their fair share. Are we obtaining adequate contributions from our allies for this very expensive project? In an era of intense global competition, the United States must do everything it can do to maintain its preeminence in scientific research and development. I share that statement, and so do all the members of this subcommittee and Chairman Conyers of the full committee. But that means that Congress must seek out and provide funding for the worthiest of projects, including some that may be too large for the private sector to undertake on its own. Every federal research dollar must be put to its best and highest use, and I trust that this hearing will lead us in that direction. The subcommittee has before it today a distinguished array of witnesses. We will first hear from the Honorable Mr. Charles Bowsher, Comptroller General of the United States of America. We will then hear from a panel of eminently qualified and respected experts in the fields of science research and space science. And finally, we will hear from Admiral Richard H. Truly, the Administrator of NASA. It is my hope that this will be a very constructive hearing, not only for the Congress, but for NASA as well, and for the American people. At this time, I'd like to ask my friend and colleague, Mr. Cox, the ranking member, for any comments he might have.
Thank you, Madam Chairman. I will have to insert a statement in the record in the interest of time, but I'd add at the outset that I support the continued development of space station freedom. And that doesn't mean that I support any bill presented to us or any cost associated with it. It is important, however, that the Congress not swim halfway across this river and then turn back. We've already invested $4.5 billion in the development of space station freedom. We've received the cooperation of Japan, Canada, and Europe in the effort. It's important that the United States be a reliable ally in this partnership and complete the development of space station freedom. Our distinguished chairwoman has stated that the subcommittee has found certain things with respect to costs. I think that that's a forgivable euphemism for what the subcommittee majority staff has found, because at least this member hasn't yet participated in any of those deliberations. Our committee's own estimate of these costs is in fact a staff estimate, and I look forward to reviewing that information as well as the considered testimony of all of the witnesses before us here today. I hope to do that with an open mind. I'll add that our investment in space is just that. It's an investment, and we have to recognize what that investment brings us in future years. We cannot expect an immediate repayment of that investment, but we should focus on some immediate facts. Our aerospace industry presently produces an enormous trade surplus, $27.2 billion in 1990. Other nations eye this jealously. They are beginning to get into this field in a big way. The United States, in order to maintain its leadership, must commit the resources necessary to the continuing development of technology. No one can say with certainty what all of the benefits of this investment will be, but some of them spring immediately to mind on the basis of past investment. Our communications technology that enabled us to prevail in Operation Desert Storm, for example, that which enabled us to follow troop movements, is a product of the development of this technology. Our miracles of medicine, from laser surgery to motorized wheelchairs, and almost the entire personal computer industry owes much to our nation's efforts in space. Laser angioplasty and catamaran nets are two unlikely products of space science development. So knowledge is power, educational power and scientific power. I don't want this country to risk being left behind in the high-stakes international race for the development of new technology. That doesn't mean that government has to do it. Government is, however, engaged already in this particular project. It's been ongoing for years. I think we've got to make sure that we use the maximum of each invested government dollar. We've got to recognize also here in the Congress that stable funding for technological programs once commenced is absolutely essential if we're going to permit our agencies to make long-term plans. I look forward, as I'm sure each of the members of this subcommittee looks forward, to receiving the testimony from our distinguished witnesses this morning, and I hope to be educated in ways that we in the Congress can make better use of our appropriations in connection with Space Station Freedom. Thank you.
Thank you very much. Yes, Mr. Zimmerman.
Thank you, Madam Chairman. I appreciate this opportunity to participate in the examination of Space Station Freedom. As a member of the Space Subcommittee of the Committee on Science, Space, and Technology, I've spent the last several weeks studying and learning about the space station. I've also spent a great deal of time studying the merits of space science and exploration. As the Chairman and the Ranking Member have said, we've derived enormous scientific and economic benefits from NASA's projects over the years, and we can derive comparable benefits from future space programs. But I don't believe that we will ever derive benefits from the scaled-down version of the space station equal to its projected costs. Because of the space station's shortcomings, I cast the lone vote against authorization for it on the Space Subcommittee last month. I believe that we must continue space exploration, however. We should do so with common sense and frugality. That's why I intend to offer a floor amendment to the NASA authorization bill tomorrow that will provide for a study by the National Academy of Sciences to determine, among other things, whether the proposed mission of the space station could be better accomplished at less cost by other means. The higher cost estimates contained in the GAO report make it more likely that NASA will run out of money before the space station is complete. And as a result, it makes looking at alternatives even more important. Those of us who care about space exploration have an obligation to pursue other options. And I'm delighted that the Chairman, in her opening remarks, has said that that's one of the purposes of today's hearing, is to explore alternative courses of action that the United States can take. Unlike in the past, I believe these options should be defined based on their scientific merits, not on the whims of congressional micromanagers. In my view, it would be grossly inappropriate for us to sit here today in judgment of NASA and its implementation of the space station program without making a full assessment of Congress's own role in these shortcomings. In large measure, Congress is to blame for the failings of the space station. NASA has had to respond repeatedly to design changes and to reduced appropriations. The result has been that the space station was designed by an appropriations subcommittee, not by scientists and engineers. We in Congress must begin working with NASA to further the goals of space exploration. I have serious reservations about the space station, as I've said, but I believe strongly in the need to continue space exploration. I hope that my colleagues on this committee won't throw the baby out with the bathwater in their enthusiasm for performing this oversight review. I ask only that you proceed with your deliberations with an open mind, and I'm confident that you will see that space science is a crucial part of this nation's future. Thank you.
I thank my colleague. I want to congratulate him on his remarks. I think he's going about this in an excellent fashion. What we have before us so far, we know that NASA has said $30 billion. We know, and we will hear shortly, that GAO has come down to $118 billion number, and the subcommittee staff that has worked for a very long time on this has come up with $180 billion number. And this is a time we must pause and reflect as to what we're getting for the promises made. And I think I would like to associate myself with the remarks of Mr. Zimmer because I think he has expressed it well, and I think his amendment will be a welcome addition to the debate on the NASA authorization. At this time, our first witness is Mr. Charles Bowsher, accompanied by Mr. Mark Gebicke. Is that right? Did I say it okay, close enough? And I wanted to note that this is the first time, as I understand it, that you've come before the Congress to testify on this particular program. Is that correct? That's correct. So we really do welcome you, and it is the practice of the subcommittee to swear in all our witnesses, and if you have no objections to that, if you would rise and raise your right hand. Do you solemnly swear the testimony you're about to give is the truth, the whole truth, and nothing but the truth, so help you God?
I do.
You may consider yourself sworn. Thank you. Mr. Bowsher, why don't you proceed with your testimony? I don't know how long your presentation is. Can you do it within about 15 minutes, do you think?
Yes. In fact, what I'd like to do, Madam Chairman, is if you would put my full testimony in the record. I have a very short testimony here that I can read in a few minutes.
Excellent. Thank you.
Yeah. Madam Chair, members of the subcommittee, we appreciate the opportunity to testify before the subcommittee today on NASA's space station program. My testimony will provide an overview of one of the most ambitious, costly, and controversial space programs the nation has ever undertaken. The station has undergone numerous reductions in its design and capability, and the program has encountered several scheduled delays. I will also discuss our concerns about the station's costs, the affordability, the intended use, and the technical challenges which have yet to be resolved. When the program began in 1984, NASA expected that by using the space shuttle, the station would be assembled in space and permanently occupied within a decade. After years of analyzing user requirements and elements to be provided by other countries, NASA selected a design to be assembled by 1994 at an estimated development cost of about $12 billion. That would be $8 billion in 1984 dollars. After a number of major design changes that reduced station capabilities, the development cost rose to $18.5 billion. And however, when the cost for the ground facilities, personnel, shuttle flights were included, the cost totaled $38.3 billion. Now, recently, in response to congressional direction, NASA once again redesigned the space station. This smaller station will be largely assembled and tested on the ground and then placed in orbit in segments. Crew-tended capability is planned by 1997, and permanent occupancy is scheduled to begin in 1999. NASA estimates the cost of the station to the permanent occupancy phase to be $30 billion. We believe the $30 billion estimate does not tell the full story for two reasons. First, it does not include the program costs that should be attributable to the space station before permanent occupancy. And second, it does not take into consideration the costs necessary to bring the station to its full capability and to maintain, supply, and operate it beyond 1999. When these costs are added together, what we actually have here is about a $118 billion program, which consists of $40 billion necessary to achieve permanent occupancy and about $78 billion to keep the station operational between the years 2000 and the year 2027. We are also concerned that NASA is not maintaining financial reserves commensurate with the program risk. NASA has never before assembled a space structure as large as the space station and cannot fully anticipate the difficulties and costs. Also, the largest cost growth in the program may occur during hardware development, which has not yet begun. Regarding the affordability of the space station program, NASA is subject to the provisions of the Omnibus Budget Reconciliation Act, which came out of the last year's budget agreement. And under the provisions of this act, NASA has to compete with other domestic agencies for funding. Thus, increases in NASA's real funding may require funding reductions in other federal programs. What will the nation receive in return for this investment? Although NASA in 1984 justified building the station based on 8 potential uses, only one remains in the current design. This design includes only provisions for a research lab for microgravity and life science, 2 scientific endeavors which many scientists believe are incompatible and are not best conducted on the same station. The original justification included uses such as a permanent observatory and manufacturing facility. The reduction of 8 uses to 1 has serious implications for the scientific benefits to be derived from the development and the operation of the station. Technical challenges also remain. Of these, the reliability of the shuttle as the sole means of launching and servicing the station is one of the most difficult to accommodate. Other challenges, such as the risk posed by the orbital debris and the lack of the emergency crew rescue vehicle, also must be addressed before the station can be permanently occupied. Although the administration has always contended that one of the reasons for building the space station is to achieve U.S. preeminence in space exploration, just recently they stated it is the most important reason and that tangible scientific benefits are not the primary reason. While no one can quantify all the benefits associated with the station, I think it is fair to say that the increased costs coupled with the diminished capabilities does raise the questions on the relative value of the station. Given the remaining technical challenges, risk may also be higher than originally expected. With these factors in mind, we believe it is important for this and other committees of the Congress to continually examine the space station program from the standpoint of schedule, risk, cost, merit, and affordability. The next significant program milestone will be the critical design review scheduled for early 1993. That concludes our statement. We'd be pleased to answer any questions.
Thank you very much, and I want to thank GAO on a continuing basis. You make us look at a reality check, and this is a reality check on the space station, and I appreciate it, and it's very straightforward. Mr. Bowsher, you have estimated the cost of developing and operating the space station to be $118 billion compared to the $30 billion that NASA has told the Congress. As you know, our subcommittee staff has developed estimates as high as $180 billion, and I know that you have, you know the accounting that they used in their procedures. In your opinion, what accounts for this difference between the 118 and the 180, and could you comment on the difference?
Yeah. The difference basically is the allocation of the cost of the shuttle. We, in our $118 billion estimate, ascribe all the costs of the shuttle basically in the years that you're building the space station to that program. But in the out years, after you've built the space station, we only ascribe the variable costs of the shuttle flights that would actually be ascribed to going to the space station for the purpose of that, not to the scientific efforts. And so that's the main difference here, whereas your staff is again, ascribed all those costs to the program.
How did you come up with your method, other than, in other words, as I see it, you're looking at the shuttle and treating it as a marginal at the margin?
Well, that's right. What we're saying is when you're using it practically full-time to build the space station, then we think that the total cost of the shuttle flights ought to be ascribed to the program. But once you have the space station built, we would attribute only the variable shuttle flights, as I say.
You indicated there are still a number of technical challenges facing the space station program. Would you identify some of the more difficult challenges that you have in mind?
Yeah. You have 2 or 3 main ones here, and that is that I think the crew rescue vehicle is the one that what might cost $1.6 billion to $3 billion is our best estimates working with NASA here. And they agree that this would be necessary if you were to have permanent occupancy there, that you would need this. And so those costs, I think, are ahead of you. You also have the centrifuge, which could cost $800 million. And then the final cost here is the $7.5 billion that we add for the shuttle flights themselves.
If I could add, Madam Chair.
Yes, please.
The orbital debris situation is one that we think is a very significant technical challenge that has to be overcome. I'm sure you realize there's quite a bit of debris floating in space in the same orbit that the space station will be orbiting the Earth. And in an earlier report that we issued about a year ago, we felt that NASA needed to instruct their contractors to crank into their estimates for building the design for the space station the increased likelihood of more and more orbital debris. And they need to take some actions in that area to fully realize that particular significant hazard. It might also be a relatively costly change to make, because the station will actually have to be built to provide more shielding from this orbital debris to protect against potential impact.
Yeah, and you also always, of course, have this software issue. In other words, one of the costs that is driving the major weapon systems of the Defense Department is the software area. And so that's a risky area in any of these programs, and I think that will be, again, in this program.
Mr. Bowsher, I don't know whether you are prepared to answer this question or not. We have a scientific panel that it will follow, and we'll direct a lot of these questions to them. As you pointed out, the space station has changed its mission, and we're down to 2 reasons for building it. Do you feel that those 2 goals that we wish, those 2 reasons, could be addressed in another type of program, a less costly program? Do you have an answer to that?
I think that would be better to get the answer from the next panel on that.
Okay.
Yeah.
Well, I want to thank you very, very much. I'll ask Mr. Cox for his questions.
Thank you, Madam Chair. I'd like to follow up on that point just briefly, because in the supplemental report and testimony that you provided today, you asked the question rhetorically, but answer it also. What will the nation receive in return for its investment? It seems to me that that is central to the report itself and to your testimony. I'd say that it's fair to infer from your testimony and the report that you're not satisfied that America will receive enough for its investment to justify it. Given that that is basically a scientific conclusion, I wonder if you can tell me upon what science you relied.
Well, it's basically, I think, the question of affordability here that you have to consider. In other words, we are running a very large deficit here. $300 billion is now conceded by OMB. If you really took away the monies that were taken from the Social Security Trust Fund and some of the other trust funds, our deficit really is as high as $400 billion. And so it seems to me that one of the issues that the Congress has got to consider here is all these major programs. In other words, are we getting as much from them as the money we're investing? There's no question, as you pointed out, Mr. Cox, we've got a lot out of the space program in years past, just no question about it. Now the question is, as we're running these very large deficits, you've got a budget cap system in here that means you have to have trade-offs. In other words, if one program expands, why other programs have to be traded off. So our main point here, one of our main points today, I think, is for the Congress to think very carefully on this program and other programs, and that is, can you afford them in light of the budgetary situation that the nation finds itself in. And although we have relied upon techniques like Graham-Rudman, they really have not worked. In other words, these are mechanical approaches that people are hoping will cut the budget deficit down. But the truth matters, in the final analysis, it will take very tough budget and program decision-making. I think we're beginning to see it now in some of the other areas, especially in the defense area, where we're actually cutting forces and streamlining some programs and that. So I think every major program, and this is one of the major programs, obviously, has to be looked upon by the Congress in the light of the budget affordability situation.
Well, I don't think there's a question at all about that. I'd like to focus more specifically on the science. You said that the space station now research laboratory for microgravity and life science isn't worth it, essentially. I wonder if you could explain that.
Yeah, we didn't, it wasn't worth it, but we're saying that it looks like the other people, like the advisor to the president and also the Augustine, have pointed that they have reservations whether it's worth it from a science point of view.
So the science that you are relying upon is specifically the science advisor to the president in the Augustine report?
In the Augustine report, that's right.
Anyone else?
Yes, I'd like to add, we interviewed ourselves
Yeah.
about 34, 35 leading scientists in both of these fields. And
Is that available to us?
sure we can make
Sure,
that
we can make that
available.
available.
Okay.
Yeah, sure.
And was there unanimity of opinion among the 34?
Not unanimity, but certainly there were a large number of those folks who led us to the conclusion, because they are the experts, that the sole reason for building the station would be for experimentation for long exposures to space by humans, plants, and animals, to prepare ourselves for possibly subsequent missions back to Moon for a longer period of time than we were there last time, or possibly on to Mars.
And that was not worthwhile?
No, not that it wasn't worthwhile, that was the principal reason for going forward with the space station, the life sciences area.
Right, I think we're agreed upon that premise. And then the question is, was it your inference or was it their direct conclusion that that was not worth the investment?
I don't think I could respond to that one way or the other. I don't think they really made a yes/no.
Okay, because I think that's the question here, and that's the question rhetorically that you posed, and seems to me answered, if not directly, then inferentially, in the negative.
Well, I don't think we're necessarily saying in the negative. If you make the decision that you want to go on to the Moon and do those experiments around to Mars, then there's obviously the life thing is what you have to know. But just getting that information, if you don't go on those additional tasks, well, I think what the scientists are raising is they're not quite sure then it's worth the investment.
Okay, because
Yeah.
obviously it doesn't matter how much or how little the space station costs. If we slash its cost in half, we'd still be saddled with the question, is it worth it? And we've got to focus on what it is we're getting in return for the investment, not just whether the number is really 30 or 50 or 100. And I take it then that your conclusions on that are either tentative or wholly reliant on others who are scientists, and therefore you don't feel comfortable reaching a solid conclusion on that subject?
Well, again, I think the conclusion we're reaching here is that the costs, you have to look at the costs, you have to look at the affordability, then you have to look at the benefits that you think you're getting.
Well, let me
And most of the
put it
scientific...
directly. Will you reach a conclusion for us on that subject?
Yeah, no, I don't believe that we should
is it worth
reach a
it?
conclusion. It should be the Congress that reaches a conclusion. I think we should be trying to give you the facts.
You want to recommend a conclusion?
Yeah, no.
So in other words, it's fair to say that your testimony today is not inconsistent with the conclusion that it's worth it.
I think you're trying to put words in my mouth here.
No, I'm trying to get an answer.
Yeah, what I'm saying is you have to look at the cost, the affordability issue. You have to look at what you're getting for the scientific efforts that can be done in the space station. It's really what you're going to do beyond the space
having
station.
invested all of this time and
It seems to be is what
effort.
the scientific community more and more is coming to, and that is if you're going to Mars, if you're going to do, an extensive space program beyond, then you need a space station probably, although there's other alternatives, but then that makes some sense. If you think you're not going to be able to afford all that in the future, then there's a question of whether the scientific value of what you'd be getting out of the space station would be sufficient for the investment.
All right. I certainly don't want to put any words in your mouth, and therefore I'll just ask an open-ended question and conclude with that. Would you or GAO be comfortable, given the state of the program, given the projected costs, making a recommendation that the program proceed or not?
I would not want to make that recommendation
Okay.
to you. In other
Thank you.
words. Yeah.
Before I call on Mr. Zimmer, I want to follow up on those questions. I don't believe it is your job to tell us whether to do it or not.
No.
We're the people in charge
You're
here.
the policy decision maker.
Exactly.
That's correct. Yeah.
And I think the purpose that you fulfill, and it's very crucial, along with the subcommittee staff, the majority that has in fact come up with these numbers, is first of all to find out what we're getting into. I mean, whether or not we want to go forward or not, I would hope that it depends upon a cost-benefit ratio. Now, reasonable people might differ, but the first part of this hearing is dedicated to what is this space station going to cost. If we are told by NASA it is $30 billion, we are told by GAO is 118, and our subcommittee staff comes up with 180, we've got a serious problem that we need to look at. The second point, and I think that you were correct to bring it up, if the whole purpose of this really is, and it looks to me like that's what the scientific community is saying, but we'll find out, to prepare us to go to Mars, we need to know that. What, Mr. Bowsher, do you understand it would cost us to go to Mars?
Well, that's a very, that estimate is not a firm estimate, but the best estimate that we have been able to see and review and everything like that might be as much as $500 billion. So that is a big, huge investment that would be made, and the country would have to be willing to afford that and willing to put. Now, one other cost in this whole thing, which we don't put into any of these estimates, but I think more and more we ought to be considering, and that's the interest cost. In other words, when we are running $300 billion, $400 billion deficits, we are adding to our debt at an extremely high rate. And as I pointed out to the Senate Armed Services Committee the other day, our interest cost has now passed defense as the largest item in the federal budget. We used to have an interest cost of $30 billion in the mid-'70s. We're now up to $300 billion. And the interest cost is rising at a relative or an approximate rate of about $25 billion. That's one of the things that is really driving this deficit. So any time that we take on these very, very large projects, if we don't have the revenue to cover the cost of them, why then what we're doing is we're adding more interest costs, more debt to the future. So I think that, as I say, that's not, interest cost is not included in any estimate on any government program, but I'm wondering now, as we run into these kind of high interest years, that the decision makers ought to have it in front of them to take into consideration. And I think it's something that's going to eat us out of house and home eventually. You know, we're up to well over $3.5 trillion of debt now. We're heading to $4 trillion. If we don't turn this trend around, we'll be up to $5 trillion of debt. And many people point out that that is not all that much versus the GNP compared to the end of World War II, but we're paying 8 and 9% on the debt. And in World War II, we were paying just slightly over 2% on long-term treasuries and less than 1% on short-term treasury. So this interest cost is becoming a big factor in what can we afford in the future. And when you think of a large space program going to Mars, that's the kind of information I think the Congress should also consider.
Mr. Bowsher, that is very sobering thought. I think you're right. I think that we need to look at interest costs now. If you look at the S&L mess, if we paid it off today, I believe it would be $50 billion. We pay it off.
No, if you paid it off today, I'm an expert on the S&L mess.
Tell me what it is. Put it in the record.
It would be about $170 billion.
And
it's $500 billion over the long term, and that does not include interest except on the REFCO bonds that we sold off budget.
What if you include interest?
If the interest, well, you could double it easily. Yeah.
$1 trillion.
Yeah.
So the S&L, if it's not paid off
Yeah.
today, is $1 trillion. Going to Mars, you're saying you've heard soft estimates of $500 billion without interest.
That's right.
So you could conceivably double that if you put interest in. Thank you. Ms. Zimmer.
Thank you. Madam Chairman, I think that discussion indicates that the Augustine Committee, which was appointed by the President to look into the space program, was correct when it suggested that we go as we pay, that is, as we can afford to proceed, we go in incremental steps. And that leads me to the question that I want to ask you. It seems that a number of the factors which give rise to your higher cost estimate are disagreements arising out of what you might call accounting conventions, whether costs that are included as fixed costs elsewhere in the budget should be allocated to the space station, or whether costs which have been pushed off beyond the horizon of the end of the century should be included as well. Could you tell me what, assuming that all your estimates are correct, what would the higher costs do on a year-to-year budget basis to the space program? How much would we in Congress have to appropriate in addition to what the projected baseline appropriations?
I think on space station what we're talking about is roughly $2 billion a year right now, and then once the program really gets in full swing, you'd probably have to add another $1 billion to that. It's hard to even speculate as to what that would be after the year 2000, particularly if you start to bring into that, as you pointed out, Mr. Zimmer, the transportation costs associated with the space station. None of NASA's estimates that we have seen, especially the $30 billion estimate, includes any transportation costs whatsoever, whether it be full costing for the shuttle or marginal cost for the shuttle after the year 1999.
Well, let's discuss pre-1999.
Okay.
How would your view of the cost of the space station affect the annual amounts of money that would be necessary to appropriate from fiscal 92 through fiscal 2000?
I don't have those numbers in front of me. I'd be glad to provide those for you.
Could you develop it?
Sure.
Because we're talking about astronomical differences, and I'd like to know whether on a year-to-year basis, if you assume, for instance, we'll be paying for the shuttle out of one pocket or another, for instance, whether the incremental cost would be dramatically higher, and it's something we need to know.
Okay. Yeah. I might, if I could point out one more point, and that is there currently is a congressional limitation on the cost of the development of the shuttle program to 25% of NASA's budget and to 10% of NASA's budget for operational expenses once the shuttle is once the station is in place. So those limitations do exist.
Okay.
I think one other point too, Mr. Zimmer, would be your the potential for cost overruns. In other words, you have to recognize that when you're in this type of a program, you could have cost overruns in the future of some substantial, and that could add to your annual thing. And what they're carrying here is reserves of, I believe it's 10% in the current year and 15% in the other. That might not be enough, you know, when you get into a program of this risk. And
well, when you submit to the committee your year-by-year analysis, if you could put as a line item in that the incremental amount of the reserve that you think is prudent,
all right,
I'd appreciate it.
Fine.
Because as Mr. Cox said, we shouldn't go halfway and stop. That's the worst thing in the world we can do.
Yeah, and by the way, I would strongly support that. I think if you go forward, a stable funding program is always the best program in this type of situation. If you get unstable funding, that runs up the cost increases very much. Yeah.
Have you investigated the cost at this point of redirecting the program away from Space Station Freedom into, say, a dedicated life science satellite plus a free flyer for materials research?
No, we've not done that.
And so you don't know how much it would save if you stripped out the material science piece, the microgravity piece from the station?
No, we don't have those figures.
Okay. I have a question about the cost of the centrifuge. During the testimony of NASA before the Space Subcommittee, NASA said that the cost of the centrifuge would be, I forget what the exact amount was, I think it was in the neighborhood of $30 million. Yet you attribute in your remarks to NASA the $800 million price tag for the centrifuge. Where did that come from?
That came from NASA. That's an $800 million figure, which includes, I guess, the construction of the centrifuge and the facility that would house the centrifuge as well.
Okay, I'd appreciate it if the NASA spokesman could address that when he's if Admiral Truly could address that when he comes up. Those are all the questions I have. Thank you.
Thank you, Mr. Zimmer. Mr. Cox.
I'd just like to return to the recommendations of the Augustine Committee, in particular because the Augustine Committee was one of two principal scientific reports upon which GAO placed reliance. Are you comfortable with the recommendations of the Augustine Committee with respect to the space station freedom? Do you think those are sound recommendations? Are they consistent with your own?
Yes, I think the main thrust there, what they were saying is the microgravity should not be the main, it should be the life science. And I think, again, what they were saying, that was based on the idea that you were going forward into space with a major program probably afterwards, and this would be the more significant thing. So I believe that that's the main decision I think the Congress and the administration has to make, and that is how much investment do you want in space over the long run, and are you going for the big efforts there? And if you are doing that, then you should be probably putting the main emphasis on the life science.
Well, in fact, the Augustine Committee recommended the long-term exploration, manned exploration of Mars.
Yeah, if you can afford it.
Yes.
Yeah.
Well, I mean, they recommended it, I think, as a specific recommendation in the report. They've also said that space station freedom should be revamped to emphasize life sciences and human space operations and include microgravity research.
Yeah.
Now, NASA is telling us that the reconfigured space station freedom, in fact, is reconfigured to follow those Augustine Committee recommendations. So I just wonder if you're comfortable with those recommendations, whether or not you think NASA is thus headed in the right direction.
Well, I think, again, Mark, some of the scientific people that we talked to had some concern about the redesign, whether you could do the microgravity within the redesign as well as maybe with the original design. So we have pointed that out in our report. But I think other than that, we're comfortable.
All right. Finally, to get at this problem of long-term cost, we don't know where space exploration is going to lead us, obviously. We're talking about a period of many, many years, and technology is changing very quickly. Is there anything in nature that requires government to undertake these expenditures, or mightn't private investment in space benefit from the space station, and mightn't that solve some of our budget problems?
It might, but I don't think we have a great history on that. In other words,
in fact, we have no history on that.
Well, and I'm also going back to the breeder program that I remember President Reagan raised that issue when the Congress was getting to the point of not wanting to fund it, and that is, would the private sector be willing to fund it because of the benefits and everything like that. And what we found out when we did that study is, I think what you find out many times, and that is, once you ask the private sector to take on a major high-risk program, they really want government guarantees. They really need government guarantees, and if you put that into the program, you generally don't reduce the cost to the taxpayer all that much. So I think it's a possibility. Maybe it's something that ought to be looked at, but I wouldn't hold it out today as a big dollar saver, you might say, for the taxpayer. I think if you're going into space, you've got to recognize the taxpayer is probably going to pay the bulk of that investment.
Thank you.
Thank you, Mr. Cox. Just a couple of points I wanted to pick up. Mr. Gebicke, you said something, and I didn't follow it exactly right, that the Congress has already said that the space station cost could be no more than 10% of NASA's budget?
Yes. I believe that's in one of the conference reports. That's operating costs for the space station, no more than 10% of the budget, and development costs of production of the space station, no more than 25% of NASA's budget.
Could you just comment on that kind of what I consider to be an artificial way to run a program? In other words, one of the problems I'm having here today is that NASA says this is $30 billion. You say it's $118 billion. The committee seem to be saying we want it, but we don't want to be accused of spending too much on it, so we'll make it X percent of the budget. It seems like an artificial way to handle a program. I mean, maybe this thing will never get done.
If I recall, some of the legislative history of that statement was that the congressional concern was that the space station not completely eat into NASA's budget, that NASA have enough money to do some of the other things that they also do in addition to the space station.
Well, it seems to me if the concern is that the space station not eat into NASA's budget, we ought to at least know what the space station will cost. As you put these percentage of budget, I mean, that seems to me to be avoiding what the true cost is. I mean, if it's going to cost $180 billion and the Congress in its wisdom decides it's worth it, that's an honest decision. If it's going to cost $500 billion without interest to go to Mars and Congress decides it's worth it, perhaps we'll cut everything out of the budget, housing, education, environmental cleanup in order to do it. That's a decision, defense, that's a decision that the Congress has to make. But it seems to me this subcommittee's interest today is to lay out what the true costs are, and you have done that very, very well in helping us make this determination. I just want to clarify something on the Augustine Commission. Is it not true that in front of Al Gore's committee recently, they said that mission to planet Earth was more important than mission from planet Earth?
That's correct.
Is that correct? I guess we'll ask that more to the scientists.
If I could go
Yes,
back to
please.
the affordability question, too, my staff just passed me up a note, which I think is good to get on the thing. They said the Augustine report also said NASA should get 10% real growth in the budget each year. And all I
That
can
means
say...
10% beyond inflation.
Yes. And so I always, when you get a special group looking at any one area, you generally get those kind of recommendations because they come from that area, and therefore, and it's very understandable. I only say again, under these budget caps, under the budget deficit, you've got to look at this affordability very carefully, I think, and not buy into automatic real growth for any one program. I think you've got to be very careful of that.
Well, we're under a pay-as-you-go budget now.
Yeah.
If we increase spending on one place, we need to cut it from another
That's
place.
correct.
So and that's good.
Yeah.
That's what we should have been
Yeah.
doing for years and
Yeah.
years and years.
If, as I've often said in the defense area, that we were able to afford, for many years, large investments and everything like that, because we were a very rich country and we were also a very competitive country. Now, as we face more competition from the rest of the world, it seems to me we've got to get this budget deficit in line, or we're going to have one big issue that makes us more and more uncompetitive.
Thank you very much, Mr. Bowsher, and thank you to the GAO, and we really appreciate your hard work on this.
Thank you.
Thank you. Call up our next panel at this time. Our panel of scientists and space experts, Dr. Louis Lanzerotti, Chairman, Space Studies Board, National Academy of Sciences. Dr. Brent Dalrymple, President-elect, American Geophysical Union. Professor Nicolaas Bloembergen, President of the American Physical Society. John Pike, Director, Space Policy Project, Federation of American Scientists. And Dr. Robert Bayuzick, Vanderbilt University. You might finish before you write. Sure, we've got to read the transcript, so we'll just go with what we'll do then. I'm going to try to hold these people a little bit. Yeah, that helps a lot, yeah. Gentlemen, if you don't mind being sworn in, I appreciate if you would rise and raise your right hand. Do you solemnly swear the testimony you're about to give is the truth, the whole truth, nothing but the truth, so help you God?
I don't know.
You may consider yourself sworn in. If it is possible, I would like to keep your comments to about 7 minutes. If you could do that, we will certainly put your entire statement into the record, but I have this little timer here when it goes off. Just try to finish up within a reasonable time. Mr. Lanzerotti, will you begin? We welcome you here. You're the Chairman, Space Studies Board of the National Academy of Sciences. We're very pleased that you're here with us. Please proceed.
Thank you. Thank you. Can you hear me now?
Yes, you can move that mic a little closer.
Thank you very much for inviting the Space Studies Board to present the views this morning. As you noted, our full testimony has been submitted for the record. The Space Studies Board was established in 1958 as the National Academy of Sciences' primary advisory body to the U.S. Civil Space Research Program. It's the Board's responsibility to provide timely and objective advice when requested by NASA or when, in the view of the Board and the National Research Council, it is appropriate and warranted to do so. Over the years, the Board has prepared and released a large number of reports and research strategies intended to promote the success and vitality of the nation's civil space research program. The Board's recommendations have been based on focused discussions among prominent researchers organized by disciplinary areas in the Board's standing committees and task groups. And these committees and task groups have addressed over the years a broad sweep of America's space science and applications disciplines, ranging from astronomy and astrophysics to Earth studies, planetary and lunar exploration. Before I proceed with the discussion of the Board's present view on requirements and issues associated with the nation's civil space station program, I'd like to take this opportunity to state clearly for the record that the Space Studies Board is not now, and has never been in the past, opposed to the concept of a national space program or to a national political goal of long-duration human spaceflight. Rather, we've confined ourselves to addressing the research and science issues if those are the national goals. There have been frequent references to a 1983 position of the Board on the scientific value of a space station. That statement, written in response to a specific request from NASA, assessed the possible utility of a space station to the accomplishment of the major scientific objectives of space research disciplines, except for microgravity, as was seen at that time. That statement concluded that most of the goals that the nation's scientists and engineers involved with space research had arrived at in terms of research strategies could be met using other means, with the exception of space biology and human adaptability and survival in long-duration human spaceflight. Subsequently, the Board has testified to Congress on these matters on numerous occasions. In addition, the Board published a research strategy for space biology and medicine in 1987, in which the requirement for a space station by these disciplines was described as pivotal if the nation is to pursue a program of human exploration. Now I want to turn to a summary of the major issues and concerns raised in the Board's March 1991 statement on the space station. As I continue to note, the Space Studies Board recognizes that there may be national imperatives for building a space station other than pure scientific research, and we did not address those. We do not feel that we have the competence among the scientists and engineers to do that any more than any other group of citizens. Therefore, the Board confined its March assessment to the station's roles in preparing for future long-duration spaceflight and in supporting microgravity research. The Board concluded that, at the present stage of redesign, Space Station Freedom does not meet the basic research requirements of the two principal scientific disciplines for which it is intended: life sciences research necessary to support the national objective of long-term human exploration of space, and microgravity research and applications. In the context of a possible national goal of mission from planet Earth, that is, human exploration, the Board emphasizes that the driving force for life sciences research is not based on abstract scientific merit, but rather on its critical role in determining the feasibility of the vision of long-duration human spaceflight. Let us talk about space biology and medicine for a moment here. The conclusion of the report of the Advisory Committee on the Future of the U.S. Space Program, chaired by Mr. Norman Augustine, and I was privileged to be a member of that committee, is that life sciences research necessary to support this country's goal of long-duration human spaceflight is the principal justification of the space station. That's recommendation number 6 of that of the committee. A conclusion which the Space Studies Board statement fully concurs. While there are scientifically interesting life science experiments that can be conducted in a low-gravity environment, these experiments alone could not justify building a space station, in the judgment of the Board. The study of space biology and medicine requires an integrated approach that includes both basic research as well as the more operational aspects of clinical research. We particularly note that many of the fundamental problems in space life sciences will require long periods of time for their pursuit and solution. The only way to execute such a research strategy is in space, with the ability to control the most critical variable, gravity. Then we laid out, and I'm trying to watch the time here, we laid out the issues related to conducting efficient human investigations in space for a national goal. Okay, thank you, and I'm nearly finished. But thank you for the timing. It's just like at the American Geophysical Union, where my colleague is the president. His chairs are also.
Time for these side comments.
Surely.
I will.
In the report of 1987, we listed a number of the scientific requirements that we thought would be, that we believed would be necessary. And they're listed in the testimony, including a dedicated life sciences laboratory, flexibility, the variable force centrifuge. Since the release of the board statement, NASA has informed us on 8 April that they're now committed to providing a 2.5-meter centrifuge on the space station. There's some problems with that, however, in terms of the timing and the planning and the budgeting for it. And I think that you explored some of those in your previous questioning this morning, and we can address some of those in the questioning later. In conclusion, while Space Station Freedom, if built according to the present restructured plan, is potentially capable over the long term of contributing to space biology and medicine, serious issues remain with respect to its timeliness, cost-effectiveness, and evolutionary planning, and I want to stress that, for establishing the feasibility of long-duration human space exploration. If the space station is to fulfill its potential for supporting this essential space life sciences research, its design and operation must be highly responsive to life sciences requirements. We've had some discussions with NASA, as I noted, since our statement was issued, in clarifying some of these matters, and we intend to continue those discussions. But at the present time, we're still concerned about the evolutionary planning to arrive at decisions at the point where we have some information that the Congress and the American people can make decisions on these matters. Thank you.
Thank you very much. Dr. Brent Dalrymple, President-elect of the American Geophysical Union. Welcome.
Thank you, Madam Chair, for giving me the opportunity to contribute to your committee's deliberations on Space Station Freedom. I am Brent Dalrymple, and I am President of the American Geophysical Union. With over 27,000 members, we're the largest scientific society devoted to the study of Earth, the planets, and their environment in space. If you recall, I think we met at the field hearing on the Loma Prieta earthquake that we hosted not too long ago. I'm also required to tell you that I am here on my own time, and I am not representing my employer, the U.S. Geological Survey. There are now a number of important and interesting problems affecting our nation and our planet, including the prediction and mitigation of natural hazards, the erosion of Earth's protective ozone shield, the depletion of natural resources, and global warming. Scientific research is critical to the solution of these problems, and space observations will play an important part in such research. The potential contributions of Space Station Freedom to these studies, however, are likely to be minimal and are not commensurate with the enormous costs involved in its construction, operation, and maintenance. Let me explain why I make that statement. First, there is little or nothing in the way of observations or experiments on Earth or its atmosphere that can be done from a manned space station that cannot be done better, less expensively, and with far less risk to human lives by unmanned satellites. The lack of any necessity for manned observations and the space station's poor geographic coverage of Earth are just two of the reasons that the American Geophysical Union has formally adopted the position that obtaining a better understanding of our home planet cannot provide a justification for Space Station Freedom. Second, it is the position of our society that Space Station Freedom should have objectives commensurate with its very large funding requirements. We're very concerned about the ultimate cost of the space station and think that it is unfortunate that no total cost for the program has been made public by NASA. Despite the lack of hard information, however, it is possible to make a rough estimate of space station cost estimates based on some of the bits and pieces of information that are available, and we have tried to do so. We estimate that Space Station Freedom will cost a minimum of $180 billion over its expected 30-year lifetime. This figure includes the costs of construction, space operation, shuttle service flights, NASA ground personnel, management, funding for experimenters, augmentations, and contingencies. We have not included funds for replacing shuttles, special ground facilities, tracking and data systems, cost overruns, or inflation. My written testimony contains information on the basis for this estimate. To put this $180 billion estimate in context, it means that the space station needs to produce more than $16 million worth of benefits, either tangible or intangible, every single day for the 30 years of its orbital lifetime just to break even. $180 billion is a lot of money for the space station to justify. I've already stated that it is the position of the American Geophysical Union that it cannot be justified on the basis of observing Earth. It also seems unlikely to us that it can be justified on the basis of observing the Moon or Mars, as was proposed as a NASA focus in the Augustine Report's Mission from Planet Earth. Until Mission from Planet Earth is defined, it's not even clear that very long exposures to zero gravity will be required, the study of which is a focus of Space Station Freedom. General science and education are other justifications for space station that have been mentioned, but the potential benefits in these areas seem to me hopelessly overpriced. For example, with the $180 billion estimate for space station, the $2.3 billion annual budget of the National Science Foundation could be tripled for nearly 40 years. As for education, I suspect that the vast majority of teachers across the country could think of a much more productive way to spend whatever portion of the $180 billion that one might assign to educational benefits. I'm also unimpressed with the justification of the space station on the basis of either space manufacturing or of national image, and have said more about these rationales in my written testimony. In summary, I believe that the advisability of continuing the program for Space Station Freedom should be evaluated on the basis of the program's real benefits and total costs. My own assessment is that the objectives, as stated so far, do not come close to justifying the enormous cost of Space Station Freedom. Furthermore, the high cost of the space station may delay meaningful progress on other NASA programs that are far more likely to produce much greater benefits and thus contribute more to U.S. leadership in space, such as Mission to Planet Earth and perhaps Mission from Planet Earth. Finally, I'd like to say that I hope my remarks are not considered to be critical of NASA. Both I personally and the American Geophysical Union are users of space data. We're supporters of both space science and NASA, and our only concern at this point is with the specific program of the space station. Madam Chair, let me thank you again for giving me this opportunity to present my views on space station, and I'll be happy to answer any questions you may have.
Thank you very much, Doctor. Professor Nicolaas Bloembergen, President, American Physical Society, welcome.
Madam Chair and members of the committee, I appreciate this opportunity to present the views of the American Physical Society on Space Station Freedom. Many of our 41,000 members have contributed directly to the space program or to the technologies that make the program possible. They have expressed increasing concern about the present direction of the United States space effort. It is the view of the American Physical Society that scientific justification is lacking for a permanently manned space station in Earth orbit. The United States needs a vigorous space science program, but such a program can be implemented for the foreseeable future with unmanned satellites and unmanned space probes. In our opinion, the importance of microgravity as a scientific subdiscipline has been vastly exaggerated. Basic research experiments that might benefit from a microgravity environment can be done and should be done first on Earth using drop towers or on unmanned space platforms. Manned space station is unsuited for microgravity research. Each movement by an astronaut shifts the center of mass of the station, producing a momentary acceleration which is equivalent to gravity. For the same reason, a manned space station is not a stable platform for astrophysical observation. And furthermore, the low Earth equatorial orbit of the Space Station Freedom would be poorly suited to Earth observations. In October, Congress directed NASA to scale down its plans for the Space Station Freedom. The Space Studies Board of the National Research Council examined the revised plan in March and concluded that the redesigned space station is unsuited to scientific research. That judgment was echoed by the White House Office of Science and Technology Policy. We agree, and indeed we believe this to have been the case even before the redesign. In our opinion, the only remaining scientific justification for the space station is to study the feasibility of maintaining human life during long space flights. In short, the only reason for putting humans into space is to learn more about how to put more humans into space. What then is the current rationale for building Space Station Freedom? In March 1991 letter from Vice President Quayle to Admiral Trudy states, the most compelling reason for building a space station is that it is a necessary step to further American leadership in exploring space. But the presence of humans is no longer essential for space exploration. Humans have proven to be expensive and unnecessary burden. It seems unconscionable to risk the lives of astronauts to perform tasks that in every instance could today be performed better and more cheaply by robots. We endorse unmanned missions as the highest expression of the curiosity that propels human exploration. And we have great admiration for the Voyager mission and others, where we explored the outer planets, places in space where no human is likely to go in the next century. The justifications that have been advanced for manned space exploration are often not persuasive. It has been asserted that the program will result in important spin-offs for industry and for society. It seems likely that any project costing 30 billion or more will produce some spin-offs. But to compete in today's markets, we need better robots, not better spacesuits. The Honorable Mr. Cox has presented some marvelous advances in technology in his earlier remarks this morning, and I concur with all those subjects. However, I wish to state categorically that they are not spin-offs of the space program. Most of those efforts would have taken place without any space program. To finish up, it has been said that it is our national destiny to send mankind into space. This is an expensive and quasi-religious tenet. If this is indeed our destiny, we should keep in mind that divine timetables are patient. Outer space and the planets will be there for millennia. With budget constraints as severe as they are today, this is not an opportune time to start preparations for a manned voyage to Mars, which would cost the staggering amounts mentioned in earlier testimony. Thank you very much.
Thank you very much. Our chairman of the Budget Committee, Mr. Leon Panetta, would welcome you as a member, I think, given your comments. Mr. John Pike, Director, Space Policy Project, Federation of American Scientists. Welcome.
Good morning. I appreciate the opportunity to discuss the space station program before this committee today. Since President Reagan's call in January of 1984 for maintaining a permanent human presence in space, the space station program has experienced a revolution of declining expectations. Initially the centerpiece of the American space program in the 21st century, with virtually every space project and experiment conducted on the station or serviced by the station, in the last 7 years, Space Station Freedom has inexorably moved away from the center of our space program. The most recent round of design changes have only served to further marginalize Space Station Freedom. Now the primary application of the station is materials research, but this direction is contrary to the Augustine panel's recommendation that, quote, Space Station Freedom be revamped to emphasize life sciences and human space operations. The commercial potential of the station and its microgravity research has been greatly oversold, and prospects that the station will actually lead to significant commercial applications are rather remote. Under current plans, we will spend over $3 billion on the Human Genome Initiative and $8 to $12 billion for the Superconducting Super Collider. The space station will be at least twice the cost of these two science projects put together. While these other science projects are addressing issues that are arguably at the forefront of science, it's entirely unclear that there are first-order scientific questions that are going to be answered by the space station. The station probably is a prerequisite for more ambitious undertakings in space, such as a moon base or a Mars expedition, but the current design for the station is not focused on supporting these more ambitious goals. Refocusing the station, as suggested by the Augustine panel, could lead to a substantially different configuration, perhaps deploying the habitation module and other life science experiments much sooner than currently planned by NASA. Alternately, a redesigned station for these purposes could be considerably less elaborate or expensive than the current baseline. The most sobering of the Augustine Committee's observations was that given reliability problems with the shuttle, that, quote, the committee believes that the administration, Congress, and the American people must be prepared for the eventuality that NASA will one day, perhaps not too far in the future, suffer another major accident, end quote. NASA's own analysis suggests that there is perhaps a 50% chance of a repetition of the Challenger accident within the next few years. Are we truly prepared to live with such a national anguish every 5 or 6 years? Are we prepared to pay the more than $10 billion that such an accident would cost? Who would recommend resuming shuttle flights after the second accident, knowing that a third tragedy could seem likely by the end of the decade? A repetition of the Challenger accident in the next few years would call into question the future of the shuttle. And without the shuttle, it's not apparent how Space Station Freedom as currently designed could be built, or how we could conduct expensive and complex scientific missions in space, such as repairing the Hubble Space Telescope. And without the shuttle or the station, it's also unclear what purposes would be served by launching astronauts into space in the near term. And without such piloted missions, it's unclear why we need a separate space agency such as NASA. And without NASA support, it's unclear that we would be spending nearly as much as we currently spend on unmanned science projects such as Hubble. Now, the Augustine report concluded, quote, that a rescue vehicle should be designed and as a contingency, provision made for an expedited development of a two-way transportation capability on a man-rateable ELV for use in the event of a space shuttle stand-down, end quote. Now, it seems to me that if one takes seriously the risk of another shuttle accident in the near term, it would seem imperative to develop such a personnel launch system on an expedited basis. Delaying deployment of the Crew Emergency Return Vehicle or the Assured Crew Return Vehicle, the ACRV, until 1999, as currently planned for the space station, places an unacceptable risk the future of the American human presence in space. Thank you.
Thank you very much for your comments. You're all staying well within the clock here. You do much better than we do. Dr. Bayuzick, Vanderbilt University, welcome. Did I say your name close enough?
That's very good.
Okay. Welcome.
Thank you. Since everyone else stayed well within their time, I guess I can take all theirs and just go on. Like everybody else, I also believe the space station cannot be justified solely on the basis of science, and all of my colleagues do the same. The motivational factor of station as a laboratory for science in low Earth orbit has to be combined with other factors to form a complete rationale. Prominent factors have already been mentioned here, human exploration of space being one. And people can go around one by one and pick these things off and isolate them and say station can't be justified on this factor. That's in fact true. What you've got to do is put them all together to get a complete justification for space station. The point is then that science remains an important but only one part of the equation for justification of station. So that if we do have a permanent facility in low Earth orbit, then we should look at the potential of that facility to be a laboratory for conducting science. Sciences that can benefit from a low Earth orbit facility are observing and sensing sciences, life sciences, and microgravity science. And what I'm going to depart a little bit from the testimony that I submitted to try and cite individual examples. It's very easy, again, to stand back and say a sweeping statement that science cannot be justified on station because you don't have to give any examples. So what I think you need to do is take a look at specific examples and say, can this particular piece of science be can be done on space station, and how and why is it an advantage to do it? And so I'm going to depart a little bit from that standpoint. I hadn't planned to do that, but since I'd already heard people make those kind of statements, I want to sort of interject that. From that standpoint, I may in fact take a few more minutes. I'll try to keep it down as much as I can, but I think it's important to lay out on the table things that you can really sink your teeth into about things that can be done on space station. With respect to the observing and sensing sciences, to be sure, that has received now low priority on the restructured station. What's left is resources along the truss, which provide power and communication links. And the question is then can these resources be used? I think the answer to that, at least on the part of people that are on my committee, and by the way, I neglected to say, I think you know, but for the record, I'm chairman of the Space Station Science and Applications Advisory Subcommittee to the Office of Space Science and Applications. That subcommittee is made up by a range of people, including observing and sensing scientists people, microgravity science people, and life science. The people on the observing, sensing side of the House, in fact, do say that given that OSSA will rescope and reconstitute attached payload program in line with the restructured station, that it can be very useful. Let me say, in fact, here's one case where I think a specific example needs to be pointed out. It was just mentioned here that the space station, because of its low Earth orbit inclination, is unsuitable for Earth observation. I've got a different opinion from people on observing and sensing scientists on the committee. What they say is because of that low inclination orbit, that an Earth-observing payload gives a higher temporal resolution look at the tropical regions than does the Earth-observing system, EOS, on its orbiting platform, which goes 85 degrees north, 85 degrees south. Space station goes 28 degrees north, 28 degrees south. Space station would give an observation roughly once every 4 days, and EOS would give an observation something like once every 16 days. Hence, on station, we get a better sampling of that particular region, and that particular region is basically the heat engine of the planet, and which drives planetary circulation. Therefore, there would be impacts for understanding long-term climate pattern, which is a key aspect of global change studies. That's not my field, but I'm just repeating what other people have told me from that particular group. With respect to life science and microgravity science, I think it's significant to use space station as a yardstick. And we can see that happening here already in terms of saying to ourselves, is continued use of space station with free flyers and so forth a more cost-effective way to go? I don't know the answer to that. That bears a lot of study, and I think it's worthwhile looking into it. But let me just sort of make some contrast between the present Space Lab program and the potential for space station. I think it's important to know, first off, that Space Lab presently you can really only fly 5 flights every 2 years because there's a turnaround problem in terms of the shuttles that will accommodate Space Lab and the various floor plans. In essence, Space Lab is always a rebuild. You're always rebuilding for a new Space Lab. Having made that introductory remark, let me run through the litany of resources. The things that are important, of course, that we want to consider are power, payload volume, crew, time in low Earth orbit, and data management. With respect to Space Lab, the power on Space Lab is 3 kilowatts to the user. On Space Station, as soon as you declare man-tented capability, you're at 13 kilowatts. You get a build in power in roughly cyclical fashion up to 30 kilowatts at PMC. If you do the arithmetic, you find out you have an increase by a factor of 10 on behalf of station. The payload volume, there are 7 double rack equivalents on Space Lab. On Space Station, there are already 7 at the beginning of MTC in early '97, and still in MTC by the fall of '97, there are 15 double racks. By the time you get to mid-'99 and PMC, there are 40 double racks. In addition, as we've already seen here, there's the intent to put the centrifuge up immediately after PMC is declared. That's an additional 5 double racks for a total of 45. The U.S. share of that, as the way things are allocated, is 31. So if, again, you do the arithmetic, you find out you've got a factor of 6 increase over the total payload volume and factor of 4 with respect to the U.S. portion. On experimental crew, given that I've already said how Space Lab needs to be manifested and planned, the experimental crew are 4, and there's sort of a hedge in that how long will Space Lab be in low Earth orbit? There are various schemes depending on how long you're ready to go with extended duration orbits. But let me just pick the number 13 days for the sake of this argument. So there are 4 crew for 13 days, and we're flying 5 for a 2-year period. There are 10 work hours per person per day. That's my estimate in terms of how much you can expect for people to work. If all those assumptions, I come up with a number of 2,600 person hours in 2 years. During MTC, the number of utilization flights are roughly on the same scheme. So during the man-tended capability era, as far as crew involvement, you have roughly about the same kind of crew involvement. So you have a wash there. The factor is 1. At PMC, there's 2 experimental crew out of a total of 4 crew. They're there every day of the year, and so there's 14,600 person hours in 2 years, again using that 10-person shift. That gives you a factor increase of 5.5. The total time in low Earth orbit is worthwhile looking at all by itself. The total time in low Earth orbit for Space Lab would be 1,560 hours in a 2-year period.
Doctor, I'm going to give you 2 more minutes
Okay.
because we're on a time pressure because the NASA people have to leave at a certain point.
Okay.
So. Okay.
For Space Station, to continue that line of thought, there's 17,520 hours in a 2-year period. That's an increase by a factor of 11. Now, if I really combine factors like the payload volume with the time that I can operate that payload volume, sparing you the arithmetic, you get a factor, if you're looking at the total space station, a factor of 72 increase payload volume hours in space, roughly, and a factor of 50 increase from the U.S. side. Point here is that, and I will sum up here, maybe I can get the opportunity to talk about specific applications. The point here is that microgravity science, for example, singling that one out, is a very embryonic field. I absolutely agree with that. The only way you make it a mature field is to give it the experimental time. You need to have that time in low Earth orbit to run experiments on a repeatable basis, on a basis of relatively easy access and rapid turnaround. Space Station is going to give that to you. I don't think a Space Lab program will. Thank you very much.
Thank you very much. Dr. Bloemgarten, do you agree with that last comment, that you need to have a space station in order to do the microgravity research?
No, I don't.
I'm sorry?
I do not agree with that statement. I think we ought to do unmanned experiments.
Doctor, I'll give you the chance to respond. Go ahead.
Unmanned experiments are done. There is a vigorous ground-based research program in place right now. At the risk of sounding immodest, and I don't mean to be, I am the #1 user of drop tubes at the Marshall Space Flight Center. We use the drop tubes at the Marshall Space Flight Center with great regularity. However, the drop tube at the Marshall Space Flight Center doesn't give us all the information we need. There's a whole set of critical experiments that we need the time in low Earth orbit to do. These are repeatable experiments. On a given specimen, I need to run basically 100 trials. To get 100 trials on Space Lab, I'll be an old man, if not no longer here, by the time I can run those 100 trials if I rely on a Space Lab program.
Let me ask you a question, Doctor. You are a proponent of going forward with the space station program. Do you put any cost limit on that?
The problem is, of course, I really can't address that. What I say is if the nation's resolve is to have a space station, we can do the science on it. I can't justify the cost of space station on the basis of science. I cannot. And neither can my colleagues.
Thank you. Dr. Lanzerotti, you talked about some problems with the centrifuge. Could you explain that? What the problems are?
No, I guess I was rushing myself at that time. What I indicated was that we had listed in the board's 1987 report a series of what we thought were the basic research requirements for carrying out space biology and medicine to ascertain the feasibility of long-duration human spaceflight. And after the appearance of our statement in March, NASA and we got together and discussed those requirements. And at that time, NASA informed us on April 8th that the centrifuge, which we had called out as being absolutely critical as a control device and as a research device, would be included in the space station program to be incorporated in the first flight after permanent man tending. And what I indicated was that the planning for the centrifuge is just starting, and the costing is not there. And of course, the research community who says that this is absolutely mandatory if we're going to have a long-duration human spaceflight program as a national objective, are concerned that without the costing, without the budgeting, without the real planning, whether that will happen or not, and on what kind of timescale necessary for national objectives and for national purposes. And the same applies to the other issues that we raised, and we're intending to continue discussing and having a dialogue with our colleagues in NASA. It's been very fruitful, the initial one we had. They were very open and friendly with us, but there's still a lot of issues related to all the other matters that we raised concerning the number of crew, concerning the dedicated life sciences laboratory. Those were the matters that I was...
So in other words, if I understand it, NASA didn't put in the centrifuge until your organization brought the issue forward.
My understanding is that the centrifuge has been thought about for many, many years, but the best information that I have from the chairman of my committee on space biology and medicine is that it was not incorporated in the station. Now, let me state also that it was not incorporated in the station prior to the restructuring. In testimony that my committee gave last year to the Gore Committee, we said that this still represents a concern for us even at that time on the station.
Is the position taken in the Space Studies Board today, in the report today, different from previous board opinions on the space station program?
No, I think we've been very consistent over the years since 1983, except for the microgravity research. In 1983, we did not have a committee on microgravity research, and so we were not able to say anything at that time. We now have a committee on microgravity research, and the National Research Council itself has had a couple of independent looks at the microgravity matter, and we can state today much more conclusively what is in our statement to NASA, what is in the statement testimony to your committee.
Are your comments solicited by NASA on a regular basis?
Well, as I indicated in the outset to my statement this morning, the oral statement, yes, they ask us many questions on most of the questions that they ask us concern some of the more unmanned aspects of the civil space program, the science and all, and we have commented to them voluntarily on a number of issues that we feel impact the research infrastructure of the United States versus the space program as well. So it's both directions.
Okay. Professor Bloembergen, I thought that your comments were very clear, and I just want to make sure that I understand them. Are you essentially saying that all of the science that we can get out of this space station, with the exception of learning more about how humans can survive, all of that can be done in a less expensive fashion and a less dangerous fashion? Is that your comment?
That's correct.
And that, am I right in extrapolating that, assuming the Congress makes a commitment to go to Mars at $500 billion, that in fact we would need the space station to do that, but barring that, you don't see any other justification. Is that a fair summary of what you've stated?
That is a fair summary. Also, if we had humans for a long time on the moon, we might want a manned space station to study conditions.
So it would be your judgment then that before we proceed with a $118 billion or $180 billion program, that we need to decide if we want to engage in a $500 billion program?
That's correct.
Dr. Dalrymple, you also, I thought, were very direct in your comments. And I don't know, I may be taking you completely off guard with this, and so if you need time to do this in writing, please feel free to tell me that. But assuming that the Congress goes forward with this, NASA comes forward today and says, you're right, Congresswoman, it's a $180 billion program or $118 billion program, and it means that we need to make a decision on a $500 billion program. If I were to ask you what you thought we could do with $180 billion to make life better for our people and advance science, do you feel you could come up with a list that easily In other words, what I'm saying is, do you feel that by moving forward with this and using these kind of resources, which are enormous, because I can't imagine any other program that's as large as this besides the military budget, which is on the down at this point, are we pushing aside other things that we could be doing to make life better for the American people?
Well, in terms of programs, I like to confine my remarks to just the few things that I know about. But in terms of NASA programs, I think we would support the Basic Sciences program, which the Augustine report said should have an inviolate part of NASA's budget. We also think there's great potential in Mission to Planet Earth. Outside of NASA, as you probably know, the science infrastructure is in serious trouble. Most of that infrastructure resides in the universities, but also in the national laboratories and in some government agencies. We think the goal of rebuilding that infrastructure by doing things like doubling the NSF budget, for example, is a worthy goal. And education certainly is in need of a shot in the arm in one way or the other at the present time. Beyond that, there are certainly social things you could do with the money. Those are not my field of expertise, and I would defer to your judgment on that sort of thing.
Mm-hmm. Mr. Pike, you talked about the fact that NASA itself says there's a 50% chance of a shuttle accident. You stressed that. And as I look over the space station, it seems to be extremely reliant on the shuttle itself. So the shuttle is an integral part. How reliable has the shuttle been thus far, in your opinion?
Well, we have approximately 40 flights now, one of which ended in a major catastrophe. Other flights have clearly had mechanical problems before launch. The orbiter that's up there right now is having a number of mechanical problems with its payloads. The fundamental problem that we have with something like the shuttle is that simply on a statistical basis, I don't think we're ever going to know how reliable it is, because even if each of the 4 orbiters flies the 100 flights that the airframe is qualified for, that's only going to give you 400 flights, which really is not much of a basis for making a statistical projection. Even if the shuttle is very reliable, in theory, in practice, the next flight could turn out to be simply an unlucky flight. And my concern is that a repetition of the Challenger accident, in the absence of sort of a plan B for how do you run a manned space program without the shuttle, could knock over the entire house of cards. Now, the station does provide in it the components for coming up with that plan B, particularly the assured crew return vehicle. My concern, though, is that all of these things are going to be coming so late in the game that it seems to me that there is an unacceptable risk that there's going to be another shuttle accident and that we aren't going to have the wherewithal to reconstitute a manned space program without the shuttle, and that would mean the end of the space program as we've known it for quite some time now.
So you think that it is necessary to have this plan B in place and not put all of our eggs in the one basket of the shuttle, because under NASA's own studies, they're saying there's a 50%
right,
chance.
Programmatically, it just seems to me to be an unacceptable risk to the entire space program to assume either that the space shuttle is not going to suffer another catastrophic accident in this decade, or to assume that politically the Congress is going to decide that even though we have a track record of the shuttle blowing up every 6 or 8 years, that we're going to start flying the shuttle again with the expectation that there's going to be another accident shortly after that. I personally think that the shuttle's highly reliable and don't think that we're ever going to have another accident. I find fewer and fewer people who agree with me in that judgment, and my concern is that if we do have another accident, that people may say we just don't want to have the risk of a third accident, and in the absence of having the station structured to provide an alternative way of running the manned space program, I would be concerned about the future of the entire enterprise.
And there is not that alternative way at this point.
Well, that's the thing that I find to be so frustrating, because there is that alternative within the space station program in terms of the assured crew return vehicle that could be put on top of an expendable launch vehicle to get the crew back and forth. You could use something like a Titan or the new launch system to put the logistics modules up and down. But my concern is that all of that stuff is happening at the end of the program in 1999 rather than happening at the beginning of the program in 1996. So my recommendation would be to pull the permanent man capability forward as soon as you can so that you have that capability in place in the event that there's a shuttle accident sooner
Why do you
rather
think
than later.
NASA did it that way? Do you think it was cost-driven? I mean,
Well, I think that there are two concerns. One of them is that the Appropriations Committee last year basically said we want a materials processing station, and the Appropriations Committee last year also said that they were unprepared to sign off on sending people to Mars. The station as currently structured is responsive to the Appropriations Committee's tasking, but as a result of that, you have the permanent human presence components of the station done later rather than sooner. And in fact, in an earlier hearing in the Appropriations Subcommittee, there was an expression that they wanted to put a firewall between the materials processing capability and the permanent manned capability, that there's still some concern on their part that they may not be interested in funding the follow-on permanent man capability. So my frustration in the station is that we have a station that may make sense politically up here on the Hill in terms of passing the budget for it, but does not make sense programmatically in terms of the logic of the space program itself.
and if I could just take your comments again and just boil it down to what you're telling me, that I'm hearing you say, is that your concern is that should there be a disaster, that could mean the end of the whole space program because of the reaction in the country, and you're fearful because you're a proponent of
Right.
it, that
Right.
we not go about this in the wrong way.
Right. Now, I mean,
That's fair.
if there is another shuttle accident, I'm probably going to be one of the people up here saying that we ought to get back in the saddle and start flying again. But given the reaction that we saw after the Challenger accident, I'm not sure that that's a judgment that the Congress is going to be prepared to make, and I'm not interested in running that experiment.
So you think it's very important that we have Plan B
Right.
implemented so that the space station isn't reliant on the shuttle exclusively?
Exactly.
Thank you very much.
Thank you.
It's been very helpful. All of you have been. Mr. Cox.
Thank you. I've been impressed with the range of opinion on a number of scientific points, and I'll just say to the panel that I think you've been very, very instructive, and I appreciate all that you have provided to us, both orally and in writing, and the written testimony is also very good. I wonder if I could start with Dr. Lanzerotti and ask a fundamental question that I believe you've addressed in your written testimony thoroughly, but I want to make sure I understand it. What could we get with a centrifuge, and why is it so important that we have this?
The centrifuge, a centrifuge sufficient in size for primates, has been one of the, quote, research requirements, unquote, of the space biology and medicine community since the board's 1987 report. It's for two purposes primarily, or three purposes: to provide an onboard 1G control for experiments. None of my colleagues involved in this research, and they're all eminent researchers doing research on the Earth, and none of them really care to go into space for going into space sake, believe that one has to have controls of experiments. That's how things are done in experimental science on the Earth. Secondly, it permits on and off acceleration for gauging the time evolution of any microgravity effects in the biological systems. And thirdly, and this is thought to be fairly important by a number of colleagues who believe, by a number of thoughtful people who believe that if the nation is going to have a long-duration human spaceflight program, we need to investigate the possibility of partial gravity countermeasures. Some of that might be able to be done on the moon, where it's a fractional gravity of the Earth, but a centrifuge will allow additional information. It may be, to take extreme scenarios, it may be never possible for a human to survive in a 10 to the minus 3 gravity environment, which one gets on a long-duration human spaceflight. However, we have no idea whether a fractional gravity would alleviate that and ameliorate it, so we don't need any more research. And so that is what the centrifuge would give us as well. There is no way to negate gravity on the surface of the Earth. There are no anti-gravity machines.
To follow up, Is it possible, in your view, that NASA could reconfigure the space station so that the centrifuge would meet your requirements?
Well, all of us here are scientists or engineers, and I'm an engineer and a scientist, and I like to engineer things, but I believe that I can't answer that question specifically. It's in real time here this morning. I believe that what one needs to do, let me make one statement. What one needs to do is to decide what one wants to do. That is, you decide what the project is that you want to carry out, if it's space exploration, and then you decide how to do it. The infrastructure that one builds should be determined by the requirements and goals. And that is my fundamental working hypothesis for my personal research. And I believe that there are elements of the space station over the last decade that have proceeded in the opposite direction. The infrastructure is defined, and then you ask what you can do with the infrastructure. And Dr. Bayuzick's comment is a little bit in that way. Given this infrastructure, yes, you might be able to do some microgravity. But if you ask yourself if you want to do microgravity, then we might get a different answer on how you do that.
Dr. Bayuzick, do you want to pick up where Dr. Lanzerotti left off?
First of all, let me comment on the centrifuge. I think the present plan on the centrifuge, where it comes up in the third node just after PMC, and that third node also accommodates the animal holding facilities and the other supportive facilities. I think the life sciences community is totally pleased with that. I don't understand what the problem is. It will be in a third node. It'll be its own mini lab. It's totally accommodated, and I think all the facilities are there to be done.
Well, Dr. Fisk testified 2 weeks ago on the 16th that with that scenario that Dr. Bayuzick just spoke of, and this scenario is, I have no problem with the scenario, but I think we need to understand what the scenario implies. There are no confirmable results in microgravity life sciences until 2007 if we proceed in this way. That's what the nation has to know, that in 2007 with a seamless, no problem program, we will begin to get the data, or we will have some confirmable data at that time to decide on whether long-duration human spaceflight is achievable or not. So I think that there is some debate in the human research community as to the appropriateness of the timing.
Do I get my opportunity now?
Certainly.
That may be so, but the point is that the operation of the centrifuge needs a dedicated crew in place, and I think we'd all agree or most people agree that to have a dedicated crew in place, you'd want the Assure Crew Return Vehicle. You need that taxi cab home, just as Dr. Pike just said. We don't want a disaster. Because of that, at least I understand from the engineers. Now, I am taking other expertise here. I'm not expert in how to build ACRVs and how quick you can do them. But near as I can tell from what I've been told is that ACRV can't be there till close to the year 2000, and therefore it makes no sense for the centrifuge to be there before the year 2000, except for short duration utilization flights. But as we just said, it's the long duration which is important. Things like bone loss, for example, and I'm not a life scientist either. I have to admit, I am also repeating what my life science colleagues tell me. I can only go on that basis. I can talk at some length at microgravity science, I think. But things like bone loss, for example, a short utilization flight of 13 days isn't going to cut it. You need to be there much longer than that. And that's true with almost everything that you want to do in space physiology and medicine. You have to be there a long time. So if Len Fisk or Lou or anybody else says that it won't be till the year 2007 that we have definitive conclusions, that may be so. The point is, you don't start till the year 2000. Maybe it takes 7 years to make your conclusions. But you can't start before the year 2000 because the ACRV won't be there before then.
Dr. Bayuzick, Dr. Bloembergen raised some worthwhile questions about the usefulness of manned space capability. And put it rather pithily that the one thing you're certain to find out with a space station is how many more people you can put in space. And I suppose that itself raises the fundamental question, do we want to? Why, in your view, is it important to have man-tended capability?
Okay, on the life sciences part, I think it's pretty clear-cut in terms of the long-term effects of gravity. And by the way, I should interject again on behalf of the life sciences community. They think it's very important to go to that 8-person crew and get there as fast as you can. The point being is to get statistically significant data. The words that would be used there is that without a more full-up crew, the data is only anecdotal in terms of telling stories, and it's not statistically significant. So I would certainly support that, getting up to an 8-person crew as often as you or as quick as you can. Okay. Other than that, there really is two aspects to station. There is the need for experimental crew, but there's also the potential for doing a lot of untended science. And I would and breaking it down the way space station is, the so-called man-tended capability error and the PMC error, in fact, gives you what that wall is. In the man-tended capability error, for example, I've already mentioned microgravity science being embryonic. There is a vigorous ground-based program, but you can't do everything on the ground. There are things you just simply need to do in low Earth orbit. Many of those things can be done in an untended mode. I can't tell you what percentage is without a full-up analysis, but many things can be done in an untended mode. So that MTC era is very important if we do it right. At this stage of the game, I don't think we can say, oh yeah, we can do it right, because it really is very dependent on teleoperations, and teleoperations is really kind of ambiguous right now. So we'd have to get busy and really define what teleoperations is and what we can do with it. But say with a vision that teleoperations can come on board, there are many things in which you could do simple commands from the Earth, automate your equipment, and do a lot of experiments in that MTC era, so that you would in fact be getting useful information much before the year 2000, hopefully in real time in the MTC era. Okay, aside from that, there is indeed also a lot of important experiments in which the crew has to be there and needs to be there in interactive mode, has to make decisions on the spot, change experimental parameters, and is not conducive to automation or teleoperations. Fluid science, fluid dynamics is, I think, a good example of that.
Mr. Pike?
Yes.
If I could just respond on one point about the relationship between the permanent man capability date and the assured crew return vehicle date. This is something of a chicken and egg problem. It's not that the PMC date is being delayed by the non-availability of the ACRV, but rather it is that the assured crew return vehicle developmental timetable is being driven by your assumption of when you want to have permanent manned capability. Now, some of the ACRV designs are basically not much more than a glorified Apollo capsule. We were able to develop the Gemini and Apollo capsules in the early 1960s in the space of a few years, and it's difficult for me to imagine that if we could do it in 3 years in the 1960s, that it's going to take us 10 years to recreate that capability today. So I think that the question of when we're going to have an assured crew return vehicle is basically something that you can decide right now. I want it in 1999 or I want it in 1996. So,
and is it fair to say you'd recommend accelerating that schedule?
I think that we ought to be doing that as
especially valuable testimony.
I thank you. If I'm not speaking for the panel on this, please let me know, because it will have to do with a question I ask NASA later. Would it be true that all of you believe that the assured crew return vehicle is an essential part of this operation, and if we didn't have it, we couldn't move forward? Is that a fair statement? Or would anyone disagree with that statement? That we need to have that? Okay. I want to thank all of you. You've been wonderful. I know it's sometimes hard for scientists to speak our language and vice versa, but I think you really did it. You tried hard to do it, and we got a lot out of this panel, all of you, and we thank you very, very much.
Thank you.
And our last panel will be NASA, and we will ask Dr. Truly to come forward. Is it Dr. Truly? Admiral Truly, forgive me. I know, okay. Okay. Admiral Truly, welcome, and we would ask if you would raise your right hand, as well as anyone else who's up there with you will be giving testimony.
If I could get you three to also, I'm just going to sit up here, but also,
Please raise your right hand. Do you solemnly swear that the testimony you are about to give is the truth, the whole truth, and nothing but the truth, so help you God? Thank you very much, and consider yourselves sworn in, and Mr. Cox will be with us shortly, and if we could begin, we'd greatly appreciate it. And I will give you 15 minutes to do your presentation.
Thank you, Madam Chair. I don't believe it'll take that long. If I
Well,
might,
if you need longer, you can have longer.
Thank you very much. If I might, I'd like to submit my written statement for the record and make a few comments.
It will be done.
First of all, let me tell you that I'm extremely pleased to be able here to represent those in NASA who are responsible and accountable for the space program, including the space station program. And also would like to say that I appreciate your comment informally prior to the hearing about the flights that are now we're now undertaking. April has been an excellent month for the space program. We have flown 2 space shuttle flights. We have rolled out the new orbiter last week on schedule and under cost. And I think the first of our 2 flights this month demonstrated extremely well what the kind of space program that America needs to have, and that is not a manned program or an unmanned program, but a balanced one, since we had trained prior to the Gamma Ray Observatory deployment for the crews to be able to take care of problems. We did send out a crew on a spacewalk, saved the Gamma Ray Observatory, and I'm pleased on your comments about it. I'm here today, of course, at your request to discuss the International Space Station Freedom, and I'd like to make that point first. We are in an international partnership with the Europeans, the Japanese, and the Canadians. They are spending their precious money, as we are, in developing Space Station Freedom, and we have important commitments back and forth to our partners, and I keep that in mind each time I discuss this program. I'm pleased to be here to discuss budgets and the cost history of the program that my friend Chuck Bowsher earlier talked to for GAO. Also to talk about the capability of the space station and the restructured program and the reasons that we have such a program in being. First, I'd like to say that the restructured space station program is in direct response to congressional direction last year. It is in response to that direction, it required that we submit a restructured program that was a phased approach and allowed for a period of time in the program that we could provide an excellent environment for microgravity research, and then eventually to build to a permanently manned capability which would allow us to do the important long-term life sciences research for the future. As a result of the congressional direction and also of the Augustine Committee, which occurred midstream in this period, we have returned to the Congress a program that does have a phased approach to it. It reduces the number of shuttle launches required to assemble and to use the space station, and therefore the cost of it. It is much easier to assemble and bring into operation on orbit because we are doing more ground checkout of various components of the space station on the ground, and particularly at the Kennedy Space Center in preparation for the launch. It has reduced by more than half the number of EVAs, extravehicular activities or spacewalks, that it requires for the men and women who will build the station to actually assemble it. And the results are consistent with the recommendations of the Augustine Committee, the National Space Policy, with our international commitments to Japan, to Canada, and to the European nations of the European Space Agency, and it does meet the budget guidelines of the Congress. This configuration does not preclude growth in the future should NASA and the Congress or the administration and the Congress agree to fund such growth. And I believe that the configuration is designed to get the maximum return on the investment for the program. In the past 7 years of the space station program, it has undergone a great deal of review, but particularly in the last year or year and a half to 2 years, it is my personal opinion that the program has come together in an excellent fashion, is under very good management control and configuration control. These reviews have been by the National Academy of Sciences, the National Research Council, the Space Studies Board, the NASA Advisory Council, the GAO, the OTA, the Augustine Committee, the Office of Management and Budget, and most recently the National Space Council. One thing that has been consistently pointed out by each of these reviews is the need for stable funding in order for NASA to do its job on the space station program. And frankly, up till now, we have not had a stable agreement with funding and projected costs, and it has caused NASA to replan the program several times. And I trust that after the debate in this Congress, that we will have an agreement, and I believe that 1991 is the year that we can stabilize the space station program. Earlier in the hearing, and I have enjoyed hearing my friends, and I admire and know, I think with one exception, every person who has testified up here. I've enjoyed hearing the back and forth in the previous witnesses. And as you and your committee asked questions of me, I will try to respond to each and every one of them. On cost, on technical risk, on science, and on leadership. In my opening statement, let me only say on the issue of cost that I want to make it very clear that I think that there are some differences in what Mr. Zimmer called accounting conventions, but there is no situation here where NASA has not provided costs on either shuttle flights, on space station development, space station operation, to the Congress, and particularly in Mr. Bowsher's testimony, all of that data originated with the NASA estimates and then their analysis on that. It was provided by us. In concluding, I would like to I mentioned cost, I mentioned science, I mentioned leadership. In concluding, I would like to conclude my remarks with some bottom lines about the total reasons for a space station program and about the importance of investing in the future by our nation. In 1961, when a Democratic President, John Kennedy, came to the Congress, the speech that he made that initiated the Apollo program was not entitled to be about space. As a matter of fact, that particular speech was entitled A Special Message on Urgent National Needs. It dealt with the problems of the country, education, housing, jobs. He did, however, during that speech, look to the future. And over the objection of all of his scientific advisors, President Kennedy recommended that the nation step up to the Apollo program, which turned out to be the greatest engineering and technological achievement of the 1960s and possibly of the 20th century. In this year, 1991, there has been a good bit of discussion here earlier about the opinions of the science advisor, Dr. Bromley, and about the forwarding to the Congress of this restructured space station program. I would like to read two short quotes. First, which is the summary in the conclusion of Dr. Bromley's report, who as science advisor advised the President on whether NASA should be permitted to go forward with this proposal. And I quote, "Having considered all of the above, we are convinced that the ultimate compelling argument for the space station configured, as the Augustine Committee has suggested, is that of a first step in a great adventure that will take mankind away from the home planet for extended periods, and is the true beginning of manned exploration of the solar system and beyond. We should not forget or minimize the importance of developing much of the space technology and know-how required for all subsequent exploration in the relatively convenient low Earth orbit environment to be occupied by the station. And therefore, we conclude that its conceptual design is appropriate to the goal of advancing man's exploration of space. Finally, after the review of the National Space Council, which included the Defense Department, the State Department, the CIA, the Science Advisor, General Scowcroft, and of course myself and others on the Council, the Vice President wrote me a letter, and again, I'd like to quote briefly from the bottom line. Quote, "The space station is an integral part of a balanced plan of future exploration, future acquisition of scientific knowledge, and future space leadership. The space station will therefore be more than a science facility and microgravity lab, more than a training facility, and more than a life science laboratory. The ultimate mission of the space station will exceed the sum of these uses. The ultimate mission is necessary to the reaffirmation of the leadership in space of the United States of America. The importance of the space station, thus, is not the size of its span or the power of its circuits. It is the size of the dream and the depth of the commitment that it represents." Vice President Quayle is saying here, "President Bush and I are prepared to make the commitment to build a permanently manned space station in this decade. We're convinced of its merit. We are committed to the balanced plan for space exploration to which the newly configured space station contributes." Finally, Madam Chair, thank you again for the opportunity to be here. I have three people with me that if I need them, I would like to have their expertise in helping answer your questions. One is the NASA Comptroller, Tom Campbell. Secondly, the Associate Administrator for Space Flight, responsible and accountable for Space Shuttle and Space Station. And thirdly, Dr. Lynn Fisk, the Associate Administrator for Space Science and Applications. I think it is time for the administration and for NASA and for the Congress to reach a consensus. It is time to give space station freedom to the international team of engineers and scientists required to build it, because I honestly believe that it is an important part of the fabric of America's civil space program, and I appreciate the opportunity to defend it to your committee today. Thank you, ma'am.
Thank you, Admiral, truly very much. What is the cost of the space station? We understand NASA said it over and over, $30 billion. Is that the cost of the program?
The $30 billion is the cost, is our estimate of the cost, including reserves, to reach the permanently manned capability, which is what we were directed to respond to.
Well, wait a minute. I understand. We're talking about a 30-year program. What is the cost of the entire program? That's what we're after. Not just to get you a garage, but to do what you need to do. What is the cost of the 30-year program?
Well, if I may, I was
Yes.
going to get directly to that. The $30 billion is our estimate of the cost, which includes the money already spent, the development costs, and the operation cost, including the reserves in the program, to get to the permanently manned capability. We do not have a good estimate of operations costs. We estimated approximately to be $2 billion per year. And so clearly, operations costs, if the station goes for 10 years, 20 years, 30 years, that's a number that can be added up. I do have some differences as to what's available to us in our ability to build the ACRV, for example, in that $30 billion. With regard to the science cost, which is a question that has been asked, when we work daily with our authorization and appropriations committees, they are fully aware of the way our accounting and our costs are done. And the science costs for the centrifuge and the life sciences missions, which have been discussed, are budgeted in our science organization. If they were not spent on space station, the science organization would spend them alternately on space lab flights or gamma ray observatories. For example, the estimate of the gamma ray observatory launched earlier this month is included in our science budget. So it is a question of accounting responsibility, not a question of hiding costs or not being coming to the Congress and describing them.
Let me try to do this another way. $30 billion is what you say it will cost to build the space station. You've not included any of the other costs that GAO talks about or our subcommittee staff. Is that correct?
The $30 billion includes development cost, operations costs to get to permanently manned capability. Within those development costs, there is a reserve across the years of averaged over that period of time for the decade of the 1990s of about 26% reserve. It is lower in the front end, but
okay, let me put it this way. We're going backwards again. I'm just trying to get to the point. I'm trying to get you to tell me what the $30 billion gets us in terms of science. What have we done? Once we've spent $30 billion, is it not so, as GAO has stated, and we have stated, by the way, we think your $30 billion is too low. The subcommittee staff thinks it's about 50. The GAO thinks it's about 40. But let's give it it's between 30 and 50. This is before we get any information, any knowledge back from the project. Is that correct?
No, that's not correct.
Okay, how many experiments will we have had by the time we've expended the $30 billion?
At the time the $30 billion is expended, we will have done a world-class microgravity program, which was directed to us by the Congress in order to build it in a phased way. And the reason that microgravity is particularly inviting to be done during that period of time is that the crews only visit the space station every few months to do the assembly flights, and in between, furnaces can be left there so that microgravity can be done. That work will be done. The simple fact is, in life sciences, is that until the space station is built and is safe to occupy, the major life sciences work cannot be done.
Well, isn't it true that you would agree that microgravity research could be done without the space station?
You could, if you wanted to design a unmanned microgravity lab, you certainly could do that. It has never been the approach that has been taken since the space station has been a program over the 7 years of this debate that could also do it.
Have you looked at the GAO's report and their $818 billion, which is what they say the space station will cost?
I read about it in the Washington Post this morning, and I've got a copy of Mr. Bowsher's testimony now. I would be happy to go down each of the items and discuss them if you would like. I'm not a CPA, but my Comptroller is here. But I'd be pleased to discuss them one by one if you like.
I think it's a lot more than CPA. For example, we're talking about the necessity to have an assured crew return vehicle. I assume you agree with that. You did not put that in your estimate. Why would you not have put that in your estimate?
Well, first of all, I did provide that to the Congress. First of all, let me start at the beginning.
Is that in the $30 billion estimate?
We believe that we can build the assured crew return vehicle essentially within the reserves of the out-year program. However, I can't state that categorically because, and the reason that it is not in our specific estimate is that we are not allowed to because the program is not designed and it requires the development of a new start with OMB. So in order to properly inform the Congress to make sure that we retained our credibility with the Congress, we identified this to the Congress and with our general estimate of its cost, which even though we don't know today whether it'll even land on water or on land, the estimate of that cost is between $1.5 billion and $2 billion.
So it isn't in the $30 billion estimate, but you think you can pick it up in the reserves?
It's impossible for me to say since we haven't done the Phase B study, and Phase B means it's a detailed technical characterization of what the vehicle will look like. However, we do, with the 26% reserves over all those years, we believe that we can pick up a major portion of the assured crew return vehicle within that area.
But it is not in the $30 billion. You basically said that it was NASA that gave all the numbers over to the GAO. Is that correct?
In listening this morning to Mr. Bowsher's testimony and reading it, I recognize NASA numbers on each of these items, and there are some differences of opinion in some of them, and I think in at least one case, our response to GAO and their question may have confused them. But in essence, all of this is NASA data as then analyzed by GAO, and I think, frankly, they've done a good job in looking at what we've provided.
Okay. If they did a good job, then when they come up with $118 billion and you come up with $30 billion, they're using your numbers. What I'd like you to do is to, in writing, not now, get back to this subcommittee with your response to their points. Because in other words, if you agree that their numbers are right, then something's wrong here. You're coming with $30 billion, they're coming with 118.
May I? Madam Chair, I will be delighted to respond in writing as you ask. There are two fundamental differences, but they're not differences or arguments. One is they have added on 27 years of operational cost, which we were requested by the Congress to come in with a development program to come to a permanently manned capability. I might point out that those are the 27 years, or if it's 35 or 25, where the payoff of the space station will be coming. The development will be an investment from this generation, and it's that kind of a difference. But it's not a, and so those are the large differences. I believe.
I understand, but it is NASA who calls this a 30-year program, and we're looking at least this chairman of the subcommittee and the chairman of the full committee, John Conyers, is concerned as we look in the future. We are as strongly for exploration as John Kennedy, one of the great leaders of my party. And I can tell you that when John Kennedy made his speech, we didn't have a deficit. And we didn't have 100,000 kids who will go to sleep tonight without a roof over their heads. So what happens is we have to look at what we're doing here, not only because it's the right thing to do, but we have to look at it in relation to what it is we're going to sacrifice, cut, either within NASA itself, for the leadership you talk about for science, or from the other parts of our program, or how we're going to ask the American people to pay for this. Now, it may be there are members of this subcommittee who are willing to pay anything for that leadership, if they think it's leadership. As far as I'm concerned, I want to make sure it gets us leadership, and I want to make sure I know exactly how much it's going to cost. It's a 30-year program. If you go into it with the $30 billion and you stop short at costing it out, you don't have much going on. So we need to know the whole cost. Does the $30 billion include the 28 racks of scientific equipment?
The accommodations for the science equipment is funded in the $30 billion. The racks themselves and the science is funded in the science budget, and I would have to, I don't have that number on the tip of my tongue.
So
it is in the NASA budget.
It's in the NASA budget somewhere else, not attributed to the space station.
Yes, it is in the science budget, just as in on today's shuttle flight. Well, this is a DOD mission, but on the, for example, the Gamma Ray Observatory on the last shuttle flight was funded in the science budget. The shuttle costs were funded in the space flight budget.
Well, I understand.
Yes, ma'am.
See, that's the problem here. The shuttle was supposed to cost $6.5 billion. It wound up costing $42 billion. That's, a 6 times difference because of the way NASA treats certain features of its programs. That's what we're trying to get to today. If you apply the same 6 times, you'll come up with $180 billion right on the nose for this project. You know, and let's get it direct. Now, what you're saying is these racks are not included in the space station program. They're included somewhere else in NASA's budget. Is that correct?
They're included in the science budget. And incidentally, I thank you for mentioning shuttle costs. I'm not sure, I don't recognize those numbers, but I'll be glad to, when I respond to your other question.
They are NASA numbers.
I'll be glad to look them up.
Well, we got those from NASA, but I would appreciate you looking at them one more time. The transportation costs, were those included in the $30 billion?
Yes, they are. There are shuttle costs included in the operations costs for the assembly flights and for the utilization flights to use the station during that the period of assembly for microgravity.
And how much per flight do you? What is your number that you give each shuttle flight? We,
in our accounting, we charge. Maybe I better.
Marginal cost average is 57.
Yeah. We charge what is called marginal costs in that estimate, which is in the neighborhood of about $60 million per flight, and that is an issue, incidentally, and a difference with what the GAO stated and the way that we charge as agreed to between our appropriation committees and the OMB. The difference simply is that there is a large, because the Space Shuttle and its transportation system was built to be robust and to be reused, cutting out a few flights does not get rid of the large costs that are represented by the infrastructure, and so it's not very useful to the Congress. Generally, the Congress wants to know if I fly this flight and then delete it out of the NASA's budget, what do I save? And that's marginal
I understand.
cost. Yeah.
And I understand that this subcommittee has a little argument with that, but that's where the difference is between our cost of this program, which is $180, and the GAO's, which is $118, is that particular item. However, as I understand it, you just count in that $30 billion the flights up to the year 1999, and then you don't cost out the transportation costs for the rest of the life of the program. Is that correct?
In the $30 billion does respond to what the Congress directed us to, which is the permanently manned capability. And as I said, if I understood...
So yes or no, you do not cost out the transportation costs to the full 30 year of the life of the program?
No, because we don't know precisely what the operations costs will be over 10 years from now.
Okay. It will even be higher, probably.
No, we think, as a matter of fact, that the $2 billion estimate is based on our experience of the 80s. And we believe that once station gets built, the development will be over, and all we'll be maintaining on the ground will be an operations capability. And frankly, I hope and believe that we can do better than that, but I don't have a good estimate, and I would be making it up if I gave it to you.
Well, I think generally what NASA does is it costs things out in today's dollars, and I would assume if we continue with inflation, that's even on the low side. None of our numbers reflect it in any way inflated dollars. So I think we've gone on the conservative side in our estimates. If you put inflated dollars in, it's off the charts. Let me ask you this. You're talking about a program now that it can accommodate 4 people, is that correct?
4 people at the time of the first ability to keep men and women permanently on orbit, yes.
Right. And at what point will you be able to accommodate 8?
That's really undecided and will have to be determined by the Congress in future appropriations as the development costs for the program begin to tail off and we have the capability to go to 8. We do have an international, as a part of our international agreements, we had originally, there are two issues in the international commitments that we recognized but didn't have to account for in this exercise because they were over the horizon of the budget years that we were dealing with. One is the requirement for 8 crew, and the second is the addition of the 4th solar panel to get to 75 kilowatts. In saying that, let me also mention that I think that is a point of where we may have confused GAO, where we answered a question perhaps in preparation for this particular hearing. We think that the costs of the 75 kilowatts is about $150 million, and the cost of the 8-man crew, depending on whether there are two ways you could do it, but it would be $300 to $600 million for a total of $450 to $750, and they estimated those two at $2.5 billion. And that $2.5 billion included a shopping list of other things that we're not committed to do, but could be appropriated in future years if the Congress, if we asked and the Congress chose to appropriate the money.
So GAO says it's $2.2 billion. You say it's $450 to $750 million to go to the 8 crew and to go to the 75 kilowatts.
Yes, and on page 10 of the written testimony, GAO, the statement is that $2.5 billion, and our estimate is less than $1 billion.
Okay. Well, let me just say this. When are we go? You have an international agreement with the Japanese, as I understand it, that they endorsed the recent redesign, but it's conditioned on the capability of going to 8 persons and 75 kilowatts. Is that correct? What year have you told them that you're going to be doing that?
We have not told them a year, and they're quite aware of that. They, what we did tell them, and we worked with them, was that they were a party. Incidentally, they were a total party to this restructuring effort, and we made it quite clear with them, and as a matter of fact, I met with them and have it in writing from them, that this proposal went to 4-man crew, and it went to whatever the kilowatts is, but it doesn't put on that final solar array to get to 75. However, that our planning in the long term, that we were going to say, speak to the White House and eventually give an approval to come to the Congress. Our long-term planning was to go to 8 men and 75 kilowatts, but we did not commit to a year.
Okay, so we're definitely going to an 8-person crew, and we're definitely going to 75 kilowatts, and that definitely is not in your $30 billion estimate. Is that correct?
That's correct. It would be, and we're only definitely going if I can later come, or another administrator can later come to the Congress and get the money appropriated. It is definitely a choice to be made to the future.
Well, I thought it was a commitment to the Japanese, and that as far as they're coming in, they have received that commitment from you that you are going to an 8.
I feel very strongly that U.S. commitments to our international partners should be honored. But the process is, in order to honor them, is that in some future year, NASA would propose those capabilities, and they would then be appropriated by the Congress.
Okay, well, in this letter that you signed, February 26, 1991, that was signed by Mr. Santo, Minister of State for Science and Technology. The letter went to you.
Yes.
This is his conclusion. He says, after consulting through the meetings, NASA's continued commitment to 75 kilowatts and an 8-man crew capability was confirmed. So
Yes.
they're moving forward based on that. So I'm assuming that this is a commitment that the Congress is going to make. And I'm trying to get at today is what is included in your $30 billion, what is not included. Going up to 8 people, going up to 75 is not in that 30. The racks are not in that 30. The transportation costs after the year 1997 are not in that 30. So I'm just trying to put this together so that at the end of this hearing, at least I, as the subcommittee chair, will understand what's in that 30 and what is not, and what the true cost of this project is. Whether I'm going to be a firm supporter of the project or not has nothing to do with first wanting to know what it is I'm a firm supporter of, what the accurate number is. And so when you make a promise to the Japanese, I assume that ought to be in the $30 billion.
Well, the Japanese, as I said, were party to this. That is a commitment on my part to plan for the power and for the 8-man crew, and we want to do it.
Okay. Mr. Cox.
Thank you. I'm enjoying this part of the hearing much more than the last part, from which I learned a lot more. Because I know a lot more about accounting than I do about life sciences, but I learned a lot more about life sciences in the last half hour than I probably did about accounting in the same period. Because I think what we're talking about here is apples and oranges. We're talking about, to put it simply, the cost of a horse versus the cost of buying a horse and feeding it hay and putting it in a barn for a very long period of time. I don't think there's much question that we're all working from approximately the same numbers, but I'd like to walk through the two sets of revised estimates that we've got from our majority staff in the subcommittee and from GAO and compare them to what NASA has got, and I think we can resolve all this in short order. The $30 billion is the base from which everyone starts. That is built into the GAO number, it's built into our subcommittee majority staff number, and it is, of course, NASA's number. Inside that $30 billion, you told us there's a reserve. How much is that reserve?
Averaged over the years of the 1990s, it averages, I believe, 26%. It is somewhat tighter in the front end, and frankly, you might appreciate this. In program management, we were willing to do that because we have been through this program and reconfigured it several times, and we want to keep new requirements out. And if we had identified reserves, large identified reserves in the front end, we think that would be harder to do. There is a risk there, which is a schedule risk only. But
okay,
it's
am I
averaged
right,
26% over the 90s.
So ballpark about $7.5 billion out of the 30?
Yes.
Okay.
Well, may I confirm that? Pardon me. The reserve is in the development of the 30. I believe that the 16.9 is development costs.
So the reserve
26% of that 16.9 is reserves. And that is the cost to actually fabricate the hardware, develop it, and so forth.
So just under $5 billion would be our reserve?
That's about right, yes.
Okay. So we've got $5 billion to cover contingencies such as the 8-man crew, for example. Now, GAO estimates that bringing the space station up to 75 kilowatts of power and reconfiguring for an 8-man crew would cost $2.5 billion. That would eat up half of that reserve. Is that right?
Yes, and that was the number that we may have confused them, but at any rate I disagree with. It's something less than $1 billion. If I might...
It's less than $1 billion, so it would eat up only a fifth of the reserve.
Yes, it's approximately, at the most, our estimate is about $750 million for those two items. But let me also make one thing clear. The ACRV, we are going to attempt to apply the reserves to it if we can manage the program that way, and that's our intent. We believe that the 75 kilowatts and the 8-man crew will be something that we'll have to come back in a future year and to the Congress for it and not apply reserves to it, because we think that probably would be too tight.
Okay. Likewise, the 28 double racks, which are estimated to cost $2.8 billion by our majority staff on the subcommittee. That comes, although technically it's in the science budget, that approximates a little more than half of our reserve. Is that right?
No, that would be, no, the reserves are maintained for contingencies within the mainline space station. The space science budget contains its own reserves to achieve, the program management of the racks. It's just that
No, I understand. I understand that NASA counts the experiments in a different budget.
Yes.
But in terms of getting a grip on order of magnitude here, we're talking about a $30 billion base number, which includes a reserve. And my point is simply this, that the double racks, the 8-person crew, the 75 kilowatts of power, all come within that reserve, even though you want to apply the reserve to different things.
We intend to manage the program in that way. It's just that the science part of the budget, the science program has its own reserves in its program, and I therefore hold the Associate Administrator for Space Science accountable for that. And those are different reserves in his budget.
Okay, that's a second useful point to explore. The panel of scientists that we had debated in part whether we ought to perform experiments on the ground or in space, or if we perform them in space, whether we ought to perform them with men and women or without. Is it fair to say, when we're talking about costing the space shuttle, that if we don't perform experiments on board, or pardon me, not the space shuttle, the space station, if we don't perform experiments on board the space station, that we simply won't perform them at all?
No, that, with the capability, unless the country decided to move away from the civil space program, we would use the capability we have to fly. For example, even though it's, I hope it doesn't happen, if space station was killed, I think you would go right back to the recommendations of the Augustine Committee, and you would use those funds in the out years to support other missions.
So if
different missions than space station, although I certainly don't recommend that.
In fact, I think I heard the panel all suggest that we pursue these experiments, and the question is how best to do it. So if we're trying to get a grip on the cost of the space station, it probably is fair to keep in a separate budget the cost of the experiments which we're going to perform in any event. I suspect that's one of the reasons NASA
and that's why we do, and essentially that's why over the years we have come to an agreement with the Congress that the space science budget gets at least about 20% of the total NASA R&D budget, and the science community elects through the monitored process how they would spend that money, and that over the years that's the way we have come to do it.
Right now, GAO suggests adding $10 billion to your $30 billion. Now we're getting the real numbers and the real variance. Yeah. They suggest adding $10 billion to your $30 billion for program costs, about 75% of which is accounted for by shuttle flights. The majority subcommittee wants to add $62 billion for operating costs, again, including in that number. Am I right? Let me add the committees here. Is the operating cost figure of $62.5 billion, is that inclusive of space shuttle, or did you put that in transportation?
It's just operations.
Operations exclusive of space shuttle.
Okay. So that is a $66 billion number then that the majority staff has come up with for transportation comprising shuttle flights. GAO, in fact, suggests that during the assembly period for the space station that we add not only the variable costs but the fixed costs of the shuttle program and include that in the cost of the space station. Do you think that that's fair?
It's fair what you said, that is what the testimony was.
I mean, do you think it's a fair accounting of the cost of the space station to add the full, not just variable, but fixed costs of the space shuttle?
It's not the agreement that we have come to over the years with the OMB and our appropriations committees as to how to provide the information to the Congress. Because, as I said, generally what the Congress wants to know is if they want to cancel a shuttle flight or add one, they need to know how much money to add or subtract from the NASA budget. And with in a case of the space shuttle, there is a large infrastructure that allows the program to operate, and so the marginal cost of a given flight is much lower. There is one other issue on space transportation that I meant to say earlier that I'd like to bring to the attention of the committee, and that is the internationals pay their own way, and so a portion of these costs on transportation, if the internationals use a space shuttle to take up a European lab or something like that, they pay us for that. And so a part of the operations costs, both in the 90s, which is in the $30 billion, and in the out years, is going to go not to the U.S. but to our partners.
All right. To recap then, the $118 billion number from GAO comprises the $30 billion that NASA has estimated the space station will cost, which itself includes a $5 billion reserve. $10 billion for program costs, about 75% of which is really the cost of the shuttle. And then $78 billion for operations beyond 1999. And that, of course, is the apples and oranges comparison, because
that is the way I understand it,
that's
yes.
the hay for the horse.
Yes.
Okay. That number, $118 billion, if one wants to include the operational costs and the shuttle costs in it, which are the big additional numbers, $118 billion has been compared to other items in the budget and so on. It seems worthwhile to point out that if we're talking about projecting costs to the year 2027, that's a year in which I would be 75 years old, and we will have had cumulatively federal budgets totaling over $50 trillion, assuming that the Congress doesn't increase our budgets between now and then. Probably not a fair assumption.
I think that's a good point. For example, the NASA budget today is, or if you average between the 91 budget and the President's request, it's in the order of $15 billion.
What is that as a percent of the total budget of the United States?
About 1% of the federal dollar goes to NASA.
Not just for the space station, but for all of NASA.
Space shuttle, space science, international cooperation, space station development, aeronautics development, education programs, paying our people, $15 billion a year. You take $15 billion multiplied by 30 years, the NASA budget over those years is $500 billion. And if you multiply that by 99, I guess that would be the federal budget in real dollar terms. So it seems to me that over those 30 years, the ops cost of whatever they're going to be, today the rough estimate is $2 billion a year, but whatever it is, represents a reasonable percentage of that investment, always for the future, that the country pays for the civil space program.
Well, enough for the numbers. I appreciate the opportunity to get this straight, because I think we are all working with different numbers, probably with the same numbers from a different perspective. Let me ask you this. If the United States pulled out of the space station program, what would our international partners do? Would they continue without us?
I think in the space program, it would be decades before we're able to retain our credibility. And Dr. Bromley, the President's science advisor, has told me, and I think he's said publicly, that across the science and technology fields, and beyond space even, that it would be a massive blow to our national credibility if we walked away from space station.
I want to explore a topic that you raised in your opening comments, education. How specifically would the space station help education?
Well, I think that NASA and our programs, which would include space station, but it's the entire fabric of our programs, of all federal agencies, I believe that NASA has something going for it, if you will, for our young people that no other agency has, and that is our programs, airplanes, spaceships, astronauts, planets, can get to kids and young kids, and we view that as a real responsibility. Somebody pointed out to me yesterday, which I never thought about it this way, that right down the street from this Congress is an Air and Space Museum that somehow attracts 10 million people a year. 10 million people. Now, obviously some of those are internationals, but they go to that museum rather than any other place in the world. It's more than any other museum in the world. Something attracts them. 10%, if those were all U.S. citizens, that represents 4% of every man, woman, and child in this country every year that is attracted to that museum. You say, what will space station itself do for education? I can't give a quantitative answer, but I do believe that once we begin to assemble the space station and have men and women in orbit permanently doing technology work and science work and flying, up and down, that will, I think that will be an extremely positive influence, but that's just a personal opinion. But we do feel very strongly about our educational programs.
Ask a final question. The panel of scientists had a dispute among themselves about whether there were any useful technological spin-offs from the space program and whether we might expect any useful technological spin-offs from completion of our mission with the space station. Specifically, Dr. Bloembergen stated categorically that these wonderful technological advances, some of which I alluded to, were not related to our space program. And on the other hand, we had Dr. Bayuzick, who said that many were in fact attributable to our space program. What's your view on that?
Well, first of all, I don't think we ought to justify the space program on spin-offs, but I think I certainly disagree with anybody that says there has not been a unbelievably strong a total spin-off in technology and competitiveness to the country brought by the civil space program. Study after study has shown that for every federal dollar that has gone into the space program in past years, that a return to the economy has come many-fold, 6, 7, 8 times. The types of people that we tend to hire to accomplish the space program are scientists, engineers, program managers, and they're the types of jobs that create communities, that create wealth. We do have in this country big problems with regard to homeless, with regard to housing, with regard to educational problems, but I think that that's just, you know, the space program is about jobs, and it's about housing, and it's about education, but it's about the future ability for the nation's economy to grow. One specific example, and I'll be quiet, is in our aeronautics research programs. The most black ink on the trade balance for this country is in the aircraft industry. And NASA, through its aeronautics research programs and working with the Boeings and the McDonnell Douglases and the companies that produce airplanes, has been a tremendous influence on the economy at a very low federal investment.
I thank you very much, and in the interest of time, I'll yield back.
Thank you.
Thank you, Mr. Cox. I agree that NASA is about jobs and it's about education. It's one of our biggest government programs. And the issue is how we spend those resources within NASA. And also, what are the resources that we need to do the things we set out to do? Now, Dr. Bromley also said in his statement, which I have here, neither the commercial processes nor the scientific merit of the microgravity experiments come close to justifying the cost and effort required to build, deploy, and operate the station. He has problems with the newly designed station, obviously. So I think that for us, we have to decide, A, what these costs really are. And I also come with some credentials. My colleague here is an expert in accounting. I'm not an expert in accounting, although I was a CPA's daughter. That's as close as I came. However, I must tell you that I was an economics major, an economics researcher, and I was a stockbroker for a while. So I've lived with numbers a long time. And frankly, I think that these numbers that you have put forward up until today, and still I'm trying to see if I can get you to add some numbers, just don't make sense with what the program really is going to cost. And, you know, I'm only here for a short period of time in my life. The costs are going to be felt by future Congresses, the decisions that we make here today. Do you agree with Mr. Zimmer, who was here earlier, who said he's going to make an amendment to ask the National Academy of Sciences to take another look at this program to see whether it is worth it prior to proceeding? Or would you oppose that kind of amendment?
I believe that the space station program has had enough reviews. It has a certain configuration that is very logical, has been developed over a long period of time. It's in the configuration that it is because it has to be visited, by space shuttles. It has to produce power. It has to produce capabilities that we've agreed with our users. And I believe that we have done a good job, and our people have done a good job in taking the direction of the Congress and of the recommendations of the Augustine Committee and come back with a restructured program we ought to move forward with. As I said in my testimony, I think it's time for the Congress to come to a decision as to whether we should move forward, and let's give this program to the engineers and let them go build it as efficiently as hopefully we built this last space shuttle. If we continue on this funding seesaw of some particular group not being quite satisfied and not being willing to compromise, and Augustine made this very clear, if that's the kind of space program we're going to have, where every group can never come together on a consensus, and we keep programs like Station on a funding seesaw, we're going to waste a huge amount of money in the future. And I think it's time to make a commitment in 1991 to go build it and let's give it to the engineers and move on to the next subject.
Well, the funding seesaw is likely to occur if the estimates are so off base with GAO, even putting our subcommittee aside. Just looking at the GAO, $30 billion compared to $118 billion. How can you expect not to have a funding seesaw if we're not looking straight ahead at these costs? I'd like to ask you if you would allow the National Academy of Public Administration to conduct an independent cost estimate of this space station.
Madam Chair, I've received your letter the other day on that possibility. We have already talked to the NAPA about what it would cost for them to hire the expertise to do the study. Their estimates range from $350,000 to I think $400,000 to $500,000. This program has undergone two independent cost reviews within NASA, one by the OMB. I would, and I signed a letter back to you, I believe, yesterday, asking if my staff and your staff could get together and even though $500,000 doesn't sound like much in some of the numbers that have been thrown around today, it is precious money to us, and I would hope that we can continue to work together before deciding whether or not to do that particular study or not.
Okay, as I understand it, NASA's controller is going to do, quote, the independent estimate. And I find that hard to, just being straightforward with you, to have NASA's controller do an independent estimate doesn't sound terribly independent.
There have been, let me answer that question in two different ways.
Okay.
First of all, inside NASA and then external to NASA. Inside NASA, I hold the program associate administrators responsible and accountable for their budgets and their programs. In the case of Space Station, not the science, but Space Station, that that associate administrator is Dr. Lenore, who is here with me, and he and his and the accounting people and the cost people at the various field centers build the budget. It's totally separate from those program AAs and their structure. I have a comptroller who has an independent cost analysis capability. And so within NASA, we do have a way so that I can get an independent estimate of what my programs are telling me. That then does become a NASA estimate. After that point in this program, we then underwent a complete OMB cost, and that was independent of NASA. They went through our books and our restructured space station program with some minor puts and takes, agreed to it. So you're right, the comptroller's look is internal to NASA, and it's not independent in that respect, but it's certainly independent of the program.
Well, if I could bring it home to what I think it is, I think it's similar to telling the IRS that I'll do my own audit, that I'll bring in my uncle. That's, in other words, I do not feel that is an independent audit, and I hope we can, what I hear you saying is you're not shutting the door on a truly outside audit. Is that correct? You're leaving the door open, and we're going to talk about it?
No, and we continually undergo external audits, cost audits, both within the administration by the OMB and by the Congress in the case of the GAO, and in special cases, studies by other agencies, and Space Station program underwent a major assessment by the National Academy, I think that was completed, I believe, in 1987 or 8. So that's fact of life in NASA. We are independently audited externally almost continually.
Well, Admiral, I sensed in your answer that nothing you've heard today here has impressed upon you that there are astronomical differences between what NASA has told the Congress about the cost of this and what GAO has found and what the subcommittee has found. I don't view this as some small difference. This is huge, astronomical differences here. And I would hope that as a result of this hearing, you would agree, because I would hate to see us have to introduce legislation to do this and start a whole argument, that we could come up with some way that we could have this audit done. Now, you mentioned that GAO has over the years audited NASA. Of course, they have come up with some very strong statements against the way you do your accounting and the way you do your reporting to the Congress. Not you personally, the agency as an institution. And again, they have said very clearly, quote, NASA has underestimated the cost for some of its major projects. Generally, the Congress does not routinely receive information on the total project costs or changes in the cost for all NASA projects. They said that in 1980. In 1988, they said, quote, NASA does not typically report the full cost of its projects to the Congress. And in March of 91, a month ago, they said current reports on cost do not include adequate information. I assume you do not agree with those comments by GAO, or do you?
Well, frankly, I have great admiration, particularly for the most recent GAO cost audit that they did of the space station that was done over the past year. I think as my financial people have read through that report, we believe that they have accurately described the history of space station costs. The thing that I must respectfully not agree with is the implication that NASA is not being forthright with the Congress with regard to future costs. And I believe that it is because I believe the way we present the cost are totally consistent with the years of work that we've done with our appropriation, particularly our appropriations committees. And I just think it's a matter of agreeing ahead of time what will be involved in those particular costs. But a good administrator of an R&D program, quite honestly, cannot give you a precise estimate of costs 11 to 30 years in the future. You just have to make some reasonable estimates and respond to the questions that the Congress provides to you.
And what are those reasonable estimates of the total cost of this program?
For the years, the ops cost?
No, for the entire program.
I would...
Do you still stick with the $30 billion? Is that what you're saying?
Yes, yes, the $30 billion pays for the development, the reserves, and the operations to get to permanently manned capability for the shuttle.
No, I'm talking about the total cost.
For the space station, I'm sorry.
I'm talking about the total cost of the program, which NASA says is a 30-year program. What are your estimates for that program? So that the Congress knows when it's getting in 1991, long after Mr. Cox and I are with our grandchildren, what then have the American people paid for this? Within the realm of possibilities. Now, the GAO says it's $118 billion. Do you agree or disagree with that?
I disagree because I can't project costs accurately and so far into the future. I don't think it's going to be that high. Furthermore, we have given to the GAO every number, as I said, the numbers that were testified to were numbers we provided to them. It's a matter of the questions we're asked by appropriation committees and what is written into the appropriation bill.
I understand that, but I'm in another committee, and I'm asking you other questions. And what I hear you saying, with all due respect, because I think you're terrific, and that's not the issue here, and I think you're honest, what I'm saying to you is if any business, when I was in the private sector, you look out ahead at what your costs are. And they do look out ahead, because if they didn't, they'd be in trouble. Now you're saying you can't come up with any costs in the future.
No, earlier, Madam Chair, on this particular question earlier, you asked me if I would answer for the record, costs, to the ground rules that you've asked for, and I certainly, will be pleased to give you an estimate. that I think will bring the numbers closer together, but I don't have that today, and I certainly don't understand the 180 billion or the 118. It's a very complex subject about how we account for the cost of the program, and it may very well end up in some differences of opinion. But in order to put things on the record here in the hearing and as we work together, I want to make sure that my answers are as clear for the cost that you've asked me about.
Your answers are very clear, and now I heard the first little movement of hope here, which says once you look at the GAO report, the numbers may come together, which I assume you mean yours are going to go up and you're going to bring theirs down. I want to just say to you, I don't want to play any games here. I'm just trying to find out what the costs are out into the future. Passing through this committee just once, I have this obligation. It's my sworn oath that I need to oversee what you're doing. And so I need to be able to truly tell the taxpayers what they're getting themselves into here in terms of costs. Now, I don't think it's complicated. I mean, that's where you and I would disagree. I don't think it's complicated to understand that not in the $30 billion is the crew return vehicle, which Mr. Cox and you agree can be paid for out of the reserves. Fine, it's not in the $30 billion. It's in the reserves. Makes the reserves lower. Transportation is included. Is not. That's $16 billion. Science experiments, $2.8 billion. Centrifuge, $1 billion. None of that in the $30 billion. And after the year 2000, operations, $62 billion. Transportation, $66 billion. I don't think it's all that difficult. Now, it may be there's some new invention that brings the cost down, or some tragedy, God help us, in the shuttle program that brings the cost up. I'm not asking you to include those negative things. I mean, let's give it the most positive spin that we can, that we get better with costs. I mean, that's not what history tells us. When you look at the shuttle program, it went up 6 times. But let's try to get our hands around this. You talked in the beginning about how the international partners are putting in their precious dollars. What are their precious dollars? How much are they putting in?
The Canadian, pardon me, if I might refer to...
Take your time.
Again, they account for costs as we do. These are development costs, not operations costs.
Mm-hmm.
The Canadian contribution is about $1 billion in U.S. dollars. The European Space Agency contribution is about $4.5 billion.
Mm-hmm.
The Japanese contribution is $2.2 billion, and to help you in comparing that to the U.S. Contribution, that compares to the 16.9 development costs. So for development of the station, not operations and not science operations, but for development, the internationals, adding up quickly, are contributing $17.7 billion to the U.S. leadership of about 16.9.
Now,
I'm sorry, pardon me, I said it wrong. 7.7, international contribution of $7.7 billion, which compares to the U.S. development contribution of, if our memory serves me right, 16.9.
okay, yeah, I think that's what you had spelled out here.
Good.
Here, it looks like 18.5, and then after the total, 16.9. That's correct. Now, as I understand it, again, the Japanese contribution is dependent upon us going to an 8-person capability.
It assumes that the U.S. will meet its international commitments,
Right.
and eventually we will have a 8-person space station.
Right. And then we have to pay, depending, again, we've got a complete divergence in estimates here. GAO says $2.2 billion. You say top of $750 million. So it's going to, according to the GAO, it's going to cost us as much as the total Japanese contribution to make that space station into what they require. So I think it's important to put that on the record.
I believe that one will be, I believe we confuse them. I think that'll be easy to bring those together, so that at least we're talking the apples and apples.
Now, assuming that you look at this GAO study and you decide that there's some merit to it, and assuming you come up in your estimate, which I don't see how you couldn't come up in your estimate if you're looking at a 30-year program. There's no way, because you yourself said you didn't look at it.
I agree. Our
years.
estimates do not include operation of the station after the year 2000. They
Exactly.
include what it takes to build the station and operate it up
Right.
till that point.
Do you think that they ought to pay more for this privilege?
The internationals?
Yeah. Or do you think they're paying
No,
enough?
I think that I was not a party to the international negotiations, but I think, in fact, that all three of our partners, the Canadians, the Europeans, and the Japanese, are bringing important developments to the International Space Station, and since they are in the ops years, have agreed, although I'm not sure what the status of those negotiations are, but they have agreed to pay their fair share of operations costs. I think that defines what I would characterize as a very solid partnership.
Well, I would just state that if, in fact, the program is not a $30 billion program, but is a $118 billion program or $180 billion or somewhere in between that their contribution seems to me to fade away, particularly the Japanese contribution, in the sense that we now have to add significantly to make this accommodate 8 people. Mr. Cox, do you have any further questions?
Sure. I'll be brief. Admiral, I'd just like to button down something that I think you've made very clear repeatedly. Your $30 billion estimate does not include, and was never intended to include, the costs of operation of the space shuttle after
That is correct.
1999.
After we achieve the permanently manned capability.
Right, because that is, in fact, the reason for the big delta between the GAO number and your $30 billion estimate. The other delta, the only remaining difference, is $10 billion of program costs that GAO wants to put in. As I understand it, 75% of that, $7.5 billion, represents shuttle operational costs. So I don't think, if I understand these numbers correctly, that we are very far apart on our numbers. The real question is whether or not, if you were coming to us proposing constructing a building, we should look at not only the bricks and mortar and land, but also the costs of putting people inside that building and operating, if it were a courthouse, for example, judges' salaries and so on, over a period of 30 years, the useful life of the building. That's not normally the way we do things, and so I understand why you are not including those in your estimate for building the space station. There is one other area that I'd like to ask about. Mr. Zimmer isn't here to do so, but he raised it in his opening remark. He said that the program has already been made more expensive by the Congress itself. And I wonder, paying all due respect to the two of us up here, if you could explain what Mr. Zimmer might have had in mind from the standpoint of NASA.
I believe that's true, although I understand it because over the years, I've been watching the Congress work with its terribly difficult macroeconomic problems. But the simple fact is that in the space business, the most efficient way to fund a program is to agree on the requirements, and then you end up with a particular development curve. And we collectively, the Congress and the administration, has never stabilized the program until this year. In this particular year, I do believe that we have the ability to do that, because one of the things that happened in last year's NASA appropriation from the Congress was that they gave us a runout. I mean, that's specific. They said we want you to assume in 1992, 93, 94, what you can actually get, and this was, they believed, to be an achievable runout. It came from the appropriations committees, not from us. And therefore, we structured this program. if you go out to the end of that equation and say, was that the cheapest way, total cost to get there, the answer is no. A cheaper way to do it would have been to build up to higher development costs earlier in the program and then be allowed. But that's why committee after committee after committee, and we say that for any program, stable, predictable funding is essential. If I might make one other comment, 3.5 years ago, I believe, we signed a contract with Rockwell International to deliver a new orbiter. The projected rollout date for the new orbiter was April 1991. They rolled out that new orbiter in April 1991, and they did it, I believe, if I have my numbers right, about $40 to $60 million below cost. The reason that was possible is that particular appropriation was a one-time appropriation in fiscal year 1987 following the Challenger accident. In other words, we had a stable design. Congress gave us the total money for the program. It allowed us to turn to the contractor and incentivize the contractor to deliver on time and under cost, and we pulled it off. I don't know of another big program like that this year anywhere in the R&D part of the government. But that is stable, predictable funding. I admit quite freely that Space Station has been a controversial program, but I see an opportunity this year to take the Congress at its word and the runout that it gave us and compare that runout to this reconstructed Space Station program and to move forward and to stabilize it. Thank you, sir.
Thank you, Admiral.
Thank you very much. I have one last question, and then I'll wrap it up. We've been talking a lot about future costs, and I understand your problem looking into the future and stating what those costs might be. Although I think it is absolutely crucial that in a 30-year program we do that, because otherwise we don't know what we're getting the taxpayers into, and we don't know whether the money is worth the reward. So I think it's crucial. I agree with GAO that the way NASA has dealt with it has not been the way NASA should deal with it. True, it is the way NASA has done it in the past. That doesn't make it right. But let me ask you about current costs. You've put a space station, a program, now that we've got it clarified, to the year 1999. Is that correct? At $30 billion, is that it? Full cost, $30 billion to 1999. Am I correct?
Yes, based on the assumptions that I testified to about the use of our reserves, yes.
All right. You've already, as I understand it, been appropriated $6.6 billion. What have we gotten for that $6.6 billion so far?
We've gotten a lot. As a matter of fact,
go through that
yes,
a little bit?
I certainly can. We have accomplished a integrated preliminary design review with all contractors and completed that last year. We have agreement on the design of subsystems, of power arrays, of structural modules. We have an operations concept that has made taken major advantage of the work we've done to reduce spacewalks in order to build a space station. We have a management system in place that has been in place now for a couple of years, which is a stability that the space program has not enjoyed, the space station program has not enjoyed earlier. And across the centers, we're well into the early development tests. For example, at the Lewis Research Center on power systems, at the Marshall Space Flight Center on environmental control systems. So, and the next major step in the program, other than obviously getting the appropriations to do the work, is to go through a critical design review. So I think that we've accomplished a great deal, and the $6.6 billion that you mentioned will be what we will have expended at the end of this year. I think as of now it's about 4.5 or 4.6 or so.
So it sounds to me you've done a lot of studies, and you've spent about a fifth of the budget. So you feel you're on track. This is what you expected to do.
No, I don't think the use of this $6.6 billion is as good as it should have been, but the reason is we have continually annually had to replan the program because we did not have a commitment from the Congress in each given year for the funds that were projected the previous year. That's why I think this year is such an opportunity. The appropriations committees gave us last fall a runout. In other words, it was them that said, we believe, as we look at our crystal ball, and I admire the problem that you work up here, but as they looked at their crystal ball, they told us what we should expect. Okay. And we have lived within those numbers.
So, but that $6.6 billion is toward the 30.
Yes, it is. That's right. The 30. As a matter of fact, it's toward the 16.9, which is the development portion of the 30.
I understand, but it's included in.
It's included in the 30. We don't have to spend it again. It's sunk costs that represent the phase of the station design that we have today.
Sunk costs. Somehow that isn't very encouraging, but I know what you mean. I understand. Let me just conclude and say this. Mr. Cox has tried to understand the work of the subcommittee staff and the GAO, and he comes out with a little bit of a different approach than I do. Up until the year 1999, we've now established, I'll wait for the bells. We've now established that the cost of the space station program is $30 billion, according to NASA, to the year 1999, and that NASA agrees today that it hasn't looked beyond the year 1999. Is that correct?
Well,
in terms of the $30 billion?
We've looked beyond it.
But you haven't costed it out?
No, in this reconstructed program, we told the Congress what the $30 billion development was and the configuration for which it stands. We also identified to the Congress the need for an ACRV rescue vehicle and our assumption that a good portion of those costs could be paid out of the reserves.
I understand. So let me just repeat it. I'm just trying to get you to answer yes or no because I'm trying to understand. The $30 billion cost that NASA has been discussing reflects the cost of the program, all the different stages till the year 1999, and within it, you will tap the reserves, or in addition to it, you will tap the reserves for the return crew vehicle. Is that correct?
We're going. Yes, that is correct. That is our intention. But since the reserve, I also wish I could give you yes or no answers.
That's all right.
But I'd rather be.
I would rather that you feel comfortable. That's fine.
To have on the record.
It's fine.
What it is. The problem with my comment about reserves and the assured return vehicle is I don't know what the assured return vehicle is going to look like. I heard one designer earlier say it might be a command module. I go to NASA and I hear people compare it to a Discovery-type capsule or a lifting body.
But we have a range, do we not?
But we do have a range. I believe that with good management of the program and with the assumption of stable funding that we can count on, that we can manage the program so that we can apply a good portion of the reserves to that vehicle. Whether or not it can all be accommodated in the reserves, I honestly don't know. But when we come up here with a new start, which is what we're required to do for that assured crew return vehicle, you will have I will have the engineering data behind me so that I can make a much more positive statement.
Okay, this subcommittee working with GAO has come up with a $2 billion figure, but that is a small point that I want to make now. The fact of the matter is that if you look at the GAO's number to the year 1999, they come up with a $40 billion cost. If you look at this subcommittee's cost, our staff comes up with a $50 billion cost. So it isn't just a matter of the out years beyond 1999, it's a very basic difference that ranges from within $10 billion difference, GAO, to $20 billion, this subcommittee, on the cost of the program through 1999. I think it is essential even if we went with your perspective, that we shouldn't bother about what goes beyond 1999, which I totally disagree with. I think that is my responsibility to future taxpayers and to this Congress and to this country. But assuming we even went with you on that and agreed with you on that, there's still a substantial difference between $30 billion, $40 billion, and $50 billion that I would hope you would be able to get this independent audit to come out with. Secondly, just because other programs and NASA don't cost programs out in this fashion into the future doesn't make it right. And as a watchdog agency, I have definite feeling that we should follow GAO's lead here and cost this program out for the life of the program so that we know what we're getting into, because the choices that we make today are the choices we must live with down the line. So I hope that what will come out of this meeting, at the minimum, first of all, I hope that Mr. Zimmer's amendment passes. I don't know if it will or not. But beside that, we need an independent audit. It is crucial here because if we don't have that, we don't know what we're walking into here. And I want us to be the preeminent leader in space. I don't think we should settle for anything less. I don't think we necessarily get that if we go with a particular program when much of the scientific community, and I understand that you at this point are saying that we should ignore that and move forward, but much of the scientific community is saying if you do this, you can't do many other things that will better the lives of Americans and indeed make us stronger. So now that we have all of this on the table, and I understand where you're coming from in terms of the estimates that you've given. In fact, they only go up to 1999. And in fact, there are disparities between the 30 billion, 40, and 50 just going up to 1999. I'm very concerned that we have this independent audit, and I will put, let me put it this way, I will work with you as closely as I can to persuade you that it is in NASA's best interest to have this independent audit and to do it as soon as we can. And I want to thank you for coming forward here and answering all these questions. We've asked you some tough ones, and you've answered them fully and completely. I appreciate that. I also want to say on the record to GAO, who may or may not still be here, how much I respect what they've done. They're challenging the way things are done around here, which has to be done because we are in an era of limits, whether we like it or not. We were told by GAO that we are spending more now on interest payments on the debt than we are on our national defense. Not to mention education, housing, environmental cleanup, everything else combined pales next to that. So therefore, when we go into new programs, it is the role of this subcommittee and the full committee to make sure we know what we're getting into. And I want to thank the scientists and GAO and NASA for helping us get a better understanding of what we're walking into with this space station program. Thank you very much.
Yes, Madam Chair would yield.
I will yield to you.
I'd just like to compliment the Chair on conducting this hearing. Obviously, the Chair and I bring different perspectives to this problem, but this is precisely the sort of thing that this subcommittee is all about. And I think the testimony today from all of our witnesses was outstanding, and I'm delighted to have had the opportunity to participate.
Thank you, Mr. Cox, very much for your comments. We stand adjourned. Thank you again.
Thank you, Madam Chair.
Thanks, Chris.
You bet.
That concludes today's hearing on the space station. And a note to join us tomorrow morning at 7:25 a.m. Eastern Time for remarks by U.S. Trade Representative Ambassador Carla Hills. She spoke earlier today about the North American Free Trade Agreement. Again, that's at 7:25 a.m. Eastern Time, 4:25 Pacific Time. We'll take a break now for a look at the schedule. Good evening. From the nation's capital, you're watching C-SPAN 2, a public service network of the cable television industry. We're taking a break now for a look at the schedule.